Hello there and welcome back to the Sleep Science. Tonight, we're taking you somewhere both infinite and impossibly small, back before the first dawn, before atoms, before existed. You probably won't survive this if we're being honest, but don't worry, it's not because of radiation or exploding galaxies, it's because your sense of time, distance and meaning will melt like butter under the heat of 1 trillion degrees. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, tell me your location and the time where you are. Are you lying in bed in London at 11:47 PM, or maybe somewhere in New Zealand where the morning sun's just peeking in? Either way, I'm glad you're here. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You drift in the dark, so dark it's not even black because black requires light to contrast against. Here, there is no light, no distance, no here. The concept of place doesn't yet apply. You're floating in an absence so complete that even floating isn't possible, but let's call it that anyway. The only thing that exists is potential, unrealized energy, compressed beyond imagination. You can't measure its density because there's no ruler, no space to stretch one out in. If you could though, it would make the core of a neutron star look as fluffy as a marshmallow. Somewhere inside that compressed everything, all the galaxies that will ever form, all the particles that will someday make you, there's tension building. Not the cinematic, string-snapping kind, but a deep physical pressure. Imagine all the mass and energy of the cosmos condensed into a speck smaller than an atom. Scientists call it a singularity, but that's really just our way of saying, we have no idea what's happening here. The laws of physics break down. Mathematics curls into a ball and cries softly in the corner, and time itself hasn't yet begun its steady march. Historians still argue whether early scientists like Georges Lemaitre, the Belgian priest and cosmologist who first proposed the idea of a primeval atom, truly understood how radical his notion was. In the 1920s, he suggested that the universe began from a single point that expanded over time, and his peers mostly patted him on the head and returned to thinking the cosmos was eternal. To be fair, the universe exploded from nothing does sound like the world's most suspicious excuse for a lab accident. You hang there, if there means anything, watching nothingness strain toward everything. The temperature is undefined, but let's just say you wouldn't want to bring a thermometer. It'd vaporize before you could even think of checking it. Time hasn't yet started ticking, but in your mind's eye you sense a countdown approaching zero. A silence that's not quite silent. A vibration without space to vibrate in. And then, for the first time ever, something happens. It's not a boom, not like a bomb or a thunderclap because sound needs air to travel through. It's more like a sudden, unstoppable swelling of existence. One moment, there's nothing. The next, everything is expanding, fast. You're pulled along as the very fabric of space unfurls like a snapping sheet. There's no center, no outside edge. Every direction is equally everywhere. You can't even point and say, that's where it began, because it's happening in all places at once. A tiny flicker of light, well, not quite light yet, more like the concept of photons still figuring out how to behave, blazes across what will become space. You can almost feel the first whispers of energy forming structure, faint blueprints of laws we now take for granted, gravity, electromagnetism, and those mysterious nuclear forces that will soon glue the universe together. Meanwhile, somewhere across the timeline, humans will one day sit beneath telescopes, sipping lukewarm coffee, arguing about whether this moment counts as the beginning or just a transition from something even stranger. Some modern cosmologists speculate about quantum foam or previous universes collapsing and rebounding. Others joke that perhaps this entire universe is just one bubble in a cosmic soda, still fizzing quietly in an unseen ocean. You, however, don't need to pick a side. You're simply watching the first heartbeat of reality. The darkness is no longer empty. It's dense, hot, seething with energy. You can't see shapes or colours yet, but you sense structure forming in the chaos. It's both violent and soothing, like listening to a storm from under warm blankets. This is the moment when potential becomes presence, when silence decides to hum. There's a quirky bit of trivia you might appreciate. At its birth, the universe didn't explode into space, it created space. That means that technically, you couldn't have stood outside it to watch the fireworks. There was no outside, Everything we know, atoms, starlight, microwave popcorn, you, was born within that swelling fabric. Kind of poetic if you think about it. And as the first trillionth of a second unfurls, temperatures soar to levels we can barely describe, around 100 billion degrees. That's hot enough to melt not just metals, but the very particles that will someday make metals possible. Quarks and gluons swirl in a hyperdense plasma, their dance too quick for even time to properly record. If this feels too vast a picture, that's okay. It's meant to. The mind isn't built for this kind of scale. Ours evolved to spot berries in bushes, not to contemplate infinities. Still, you can try. Imagine the entire visible universe condensed into a pinprick, then watch that point inflate faster than light itself, like an air bubble expanding inside a glass of water that isn't there yet. You breathe out slowly. The thought alone makes your chest feel tight, but in a strangely comforting way. Because even in this chaos, this absolute, unimaginable beginning, there's a rhythm forming. Patterns will soon emerge, laws will crystallize. The universe is young, wild and noisy, but it's also filled with promise. And as you float among these newborn forces, you realize something oddly calming. Everything that will ever exist is already here. Every galaxy, every atom, every moment of love or loss tucked invisibly within this newborn expanse. The story hasn't unfolded yet, but it's already written into the laws that are solidifying around you. The void no longer feels so lonely. You drift a little closer now, drawn toward the dense, trembling point that used to be everything. It's not glowing like a star or flashing like lightning. It's beyond light, beyond colour. Imagine the heaviest thought you've ever had condensed into a single point. That's roughly the density we're talking about here. Scientists call it the singularity, though that word feels a bit too neat for something that makes physics throw up its hands in surrender. The singularity is where our math stops working, and yet it's where everything starts. You watch it pulse. Not with time, because time hasn't officially clocked in yet, but with a kind of tension that feels alive. The energy inside is trapped, desperate to expand, but there's no where for it to expand into. So it cheats. It stretches space itself, creating room as it grows. You can't help but smirk. This is the cosmic equivalent of starting a business and building the market at the same time. Historians still argue whether the phrase Big Bang was ever meant to sound so dramatic. In truth, it began as a joke. The British astronomer Fred Hoyle used it sarcastically during a 1949 BBC radio broadcast to mock the idea of a universe that had a beginning. Hoyle was a fan of the steady-state model, where matter continually pops into existence to keep the cosmos eternal and unchanging. He tossed out Big Bang as a throwaway phrase, and it stuck. So, technically, the name of our universe began as a burn. The pressure inside the singularity is staggering, infinite in theory. It's so tightly packed that the four fundamental forces we know today, gravity, electromagnetism, and the two nuclear forces, don't exist separately yet. They're fused into one grand mysterious interaction. Later, as the universe expands and cools, they'll peel apart one by one, like different instruments tuning after a chaotic symphony opening. But right now, it's all one deafening note. You picture yourself at the brink, though brink is meaningless when there's no edge. You reach out, metaphorically, because there's no you to reach, and everything explodes outward. Or maybe expands is a kinder word. No shrapnel, no debris, just pure energy unfurling, turning potential into presence. Within the first 10 to the minus 43 seconds, what physicists call the Planck time, the universe jumps from zero size to something with actual dimensions. The energy is so high that quantum gravity, the unholy union of relativity and quantum mechanics, rules everything, but we don't yet have the tools to describe it. It's like trying to write poetry about a hurricane while you're still in it. A quirky historical tidbit. When Einstein first applied his equations to the cosmos, they suggested it should be expanding. He didn't like that. The idea of a changing universe felt philosophically untidy, so he inserted a cosmological constant to hold everything steady. Years later, when Hubble showed that galaxies were indeed moving apart, Einstein reportedly called that constant his greatest blunder. Historians still argue whether he actually said those words, but it's comforting to imagine even the smartest minds occasionally muttering, "Well, that didn't age well." Back in the newborn universe, expansion is happening everywhere at once. The energy density is unimaginable, the temperature hundreds of billions of degrees. Every particle that will ever exist is already encoded in the chaos. Quarks, leptons, photons, the raw ingredients of reality. But they're still trapped in a swirling soup, too hot and dense to behave independently. Imagine being a raisin in bread dough that's rising faster than you can even comprehend. The raisins aren't flying through pre-existing space. Space itself is stretching between them. That's what's happening on a cosmic scale. We might expect this to feel violent, but it's oddly rhythmic. The universe breathes out, expanding. Pressure drops, temperature cools by fractions of degrees. Somewhere in this chaos, quantum fluctuations, tiny wrinkles in the energy field, flicker in and out of existence. They seem insignificant now, but those tiny imperfections will someday decide where galaxies form. It's like watching the faint fingerprints of fate press into wet clay. You drift through the boiling fabric. The pressure pushes against your awareness like a current, and for a brief moment, you sense the beginnings of structure. Not physical yet, but potential. Patterns shimmer just beneath the surface, mathematical and elegant. Symmetry dominates everything for now, perfect and unstable. In a few fractions of a second, that symmetry will break, unleashing the distinct forces that govern the cosmos. It's strange how beauty and imperfection seem to go hand in hand, even at this scale. The singularity's expansion is so rapid that talking about speed doesn't make sense. Nothing is moving through space faster than light. Rather, space itself is stretching faster than light can keep up. Light, that future cosmic speed limit, hasn't yet been handed the rulebook. You could say the universe is still setting the speed limits as it goes. Somehow that feels very human. And though you can't feel heat in any meaningful sense, you imagine it anyway. The pressure, the glow, the barely controlled eruption. You can almost hear it. A soft, low hum, like white noise at the edge of perception. Maybe that's just your brain trying to give sound to something beyond experience. Still, the hum feels comforting, like a fan running in the background of infinity. In this first cosmic moment, everything is compressed, hot, and utterly unstable. Expansion doesn't calm the chaos, it feeds it. With every instant, energy dilutes, temperature drops, and conditions shift. The singularity is no longer a point, it's a rapidly inflating cloud of pure potential. Space and time are growing together, inseparable twins, defining one another as they stretch. You catch yourself wondering what before this meant. The question doesn't make sense here. Before is a time word, and time is a property of the universe that's only just begun. Asking what came before the Big Bang is like asking what's north of the North Pole. It's not forbidden, it's just meaningless. Still, the curiosity hums quietly, the same curiosity that will one day make humans build telescopes, write equations, and whisper their questions into the dark. So you let the question go. The singularity expands, and in doing so creates not only the stage but the act itself. You drift along the newborn currents of time, feeling the first faint tick of existence like a heartbeat deep within silence. And though everything around you is chaos, it's a beautiful kind of chaos. Structured, inevitable, and oddly serene. You take a slow breath, though there's no air. The singularity is gone now, not destroyed, but transformed. Its tension released into the open, its mystery scattered into the infinite. The universe has begun, and with it, so have you. You're suspended in the first fraction of a second after the Big Bang, a time so short that even your thoughts would lag behind reality if they tried to keep up. Everything that exists is hotter than any star that will ever shine, denser than any black hole that will ever form. The universe is a seething, blinding blur of energy, expanding faster than light itself, and yet, paradoxically, it feels calm, as though you're floating inside the breath between heartbeats. This moment is called the Planck epoch, and it lasts less than 10 to the power of minus 43 seconds. Yes, that's 1 septillionth of a second. Don't bother trying to count it, it's already over. In this unimaginably brief sliver of time, the laws of physics as we know them simply don't apply. Gravity isn't separate from the other forces yet. All 4 fundamental interactions are still woven together into one unified fabric, like melted crayons that haven't cooled into distinct colours. You can sense, almost intuitively, that the pressure inside this primordial storm is staggering. It's the kind of energy that would make the core of a supernova look like a scented candle. The temperature hovers around 10 to the power of 32 Kelvin. Too hot for atoms, too hot for protons, too hot for literally anything solid. You aren't standing in fire, you're inside an entire universe made of it. But this isn't chaos without purpose. This heat is potential energy waiting to cool just enough to start building the structures that will one day sparkle across the cosmos. Scientists refer to this fleeting time as the domain of quantum gravity, though the exact details remain maddeningly mysterious. Historians still argue whether Stephen Hawking truly believed that a complete theory of everything could ever unify quantum mechanics and general relativity. The equations come close, so very close, but always seem to slip away at the tiniest scales, like trying to grab smoke with your hands. Maybe that's the universe's way of keeping a few secrets. As the first infinitesimal moment passes, the expansion slows just enough for the universe to cool slightly. Only slightly, down to about 10 to the 27th Kelvin, which is still catastrophically hot. But that subtle change means something profound happens. The great unification begins to break. Gravity starts to peel away from the other forces, setting the stage for the cosmic choreography to come. Space stretches, time stabilizes, and energy begins to organize itself into patterns. You watch the process unfold like a slow exhale, even though it's happening faster than any explosion imaginable. The dense fog of pure energy begins to form virtual particles, tiny flickers of existence that appear and vanish within a heartbeat of reality. Quarks, leptons, and bosons dance into being, colliding, annihilating, and reforming in a furious cycle. It's as though the universe is testing out building blocks, rolling dice over and over until it finds the right combination to stick. Here's a quirky fact to keep your neurons awake. The energy density during this phase was roughly equivalent to 10 to the power of 96 kilograms per cubic meter. To put that in perspective, a single teaspoon of this primordial soup would weigh more than all the mountains on Earth combined. And yet, despite that crushing density, you wouldn't be crushed, because everything is expanding together. There's no outside to compare against, no wall to hit, no edge to press against. Expansion is the rule, and every point in space is racing away from every other. For a moment you wonder what it would look like if you could actually see it, the first flash of existence. But there's no light yet, not in the way your eyes understand it. Photons are constantly colliding with other particles, unable to travel freely. You're in a universe without transparency, a fog of energy so thick that even the concept of seeing doesn't make sense. Still, your mind insists on imagining. Maybe it looks like golden plasma, shimmering and endless, the way sunlight dances behind closed eyelids. Time, that newborn dimension, begins to stretch forward in measurable beats. 1/10,000th of a second passes, then another. You feel the pace of creation slow ever so slightly, as if the universe is catching its breath after the rush of birth. The rapid expansion continues, but it's more graceful now, a steady rhythm replacing the wild convulsions of the first instant. During this early period, physicists believe something extraordinary might have happened, a brief but staggering inflationary burst. In less than a heartbeat, the universe expanded exponentially, doubling in size again and again, faster than light, faster than imagination. This sudden growth smoothed out the wrinkles of space-time, turning chaos into cosmic order. Some theories even suggest that tiny quantum fluctuations, those minuscule ripples in the energy field, were stretched across vast distances, eventually becoming the seeds of galaxies and clusters. It's mind-bending to think that the pattern of stars above you tonight might trace back to random quantum jitters from this instant. And yet, for all its grandeur, this period feels strangely intimate. You can sense the universe learning to breathe, learning to balance its equations. The expansion cools the firestorm, the pressure drops, and symmetry continues to break. First gravity, then the strong nuclear force, then electromagnetism, and the weak nuclear force separating like strands of DNA unzipping. The laws of physics, those ancient commandments, are being written line by line. There's a soft humour in it too. Somewhere down the line, entire civilizations will spend millennia trying to decode what's happening right now. They'll build colliders that smash atoms apart just to glimpse this moment in miniature. And even then, they'll admit they're guessing. You can almost imagine the universe smirking, keeping its ultimate secrets just beyond human reach, because a little mystery makes the story better, doesn't it? The seconds tick forward, and the expansion becomes more orderly. You begin to feel, deep down, that this explosive beginning isn't random. It's sculpted by laws that are both simple and profound. Energy cools into matter, matter organizes into structure, and structure will someday wonder where it came from. The symmetry breaks, but beauty emerges from it. For now, you just drift in the luminous fog, feeling the pulse of a young cosmos expanding all around you. You can't see stars yet, or galaxies, or even atoms, but they're coming. Their blueprints are already imprinted in the fabric of reality, written in vibrations woven into the hum of space-time. The first fraction of a second may be ending, but the story of creation has only just begun. And you, lucky observer, have front-row seats to everything that will ever be. You drift farther out, though out is still a word that doesn't really fit. There's no edge to this new universe, only expansion, only stretching. You're gliding through the era scientists call cosmic inflation, a moment so brief and yet so crucial that without it, the stars above your head today might never have existed. It happens roughly 10 to the minus 36 seconds after the Big Bang, before there are atoms, before there's light, before the laws of physics have even finished settling on their final forms. You're floating in the middle of a balloon that's swelling faster than comprehension allows, a balloon that isn't inflating into anything, but creating the very concept of into as it goes. At this stage, the universe isn't just expanding, it's doubling in size again and again, dozens of times in the blink of an eye. Picture this. If the universe before inflation was the size of a proton, by the end of this phase it's grown to something closer to the size of a grapefruit. That doesn't sound like much, but remember, we're talking about the entire universe. Space itself is stretching so quickly that distant points are being torn apart faster than light could ever bridge the gap. Einstein's cosmic speed limit doesn't apply yet, because it only governs motion through space, not the expansion of space itself. A neat loophole if you think about it. The energy driving this explosive growth comes from what physicists call the inflaton field, a mysterious quantum energy that saturates the early cosmos. It's like a cosmic elastic band stretched too tight, snapping outward to release its stored potential. The result? A universe that suddenly goes from quantum size to astronomically large. Inflation smooths out wrinkles in the early fabric of space-time, ironing the chaos into something remarkably uniform. Without this, the cosmos would be a patchwork of uneven densities, a lumpy mess where gravity couldn't pull matter together to form galaxies or stars. Instead, inflation sets the stage for elegance, a vast, nearly uniform sea of energy with just the right imperfections for structure to bloom later. Those imperfections, the tiny quantum fluctuations jittering in the inflaton field, are crucial. You can almost see them now, faint ripples flickering through the fabric of reality. They're so small that at first they seem meaningless. But when the universe expands, those microscopic wrinkles stretch into vast patterns spanning light years. Billions of years later, those ripples will decide where galaxies gather and where voids remain empty. You might think of them as the universe's first doodles, scribbles in the margins of creation that one day become constellations. Historians still argue whether Alan Guth, the physicist who first proposed inflation in 1980, truly understood how revolutionary his idea would be. His equations were born from frustration, trying to fix mathematical inconsistencies in earlier Big Bang models, and yet they transformed cosmology forever. A quirky tidbit, Guth's notebook entry for the night he realised his theory worked simply reads, "Spectacular realisation." All caps, double underlined. Not exactly a humble reaction, but honestly he earned it. You continue gliding through the inflating expanse. It feels paradoxical, both incredibly fast and eerily still. The expansion is uniform, so even as everything grows apart, there's no wind, no shockwave, no sound, just a soft swelling, like dough rising in slow motion, except the oven is infinite and the dough is everything that will ever be. The temperature, once incomprehensibly high, begins to fall. By the end of inflation, the universe cools to about 10 to the 27th Kelvin, a drop that would still vaporize any matter instantly, but compared to the original inferno, it's downright cozy. The universe at this point is like a blank canvas, vast and nearly featureless, but full of potential. You might think that makes it boring, but look closer. Those stretched out quantum ripples are everywhere, frozen into the expanding fabric. They're faint, but they hold the fingerprints of what's to come. If you could fast forward through cosmic time, those ripples would condense into filaments of galaxies, great webs of matter and dark energy filling the gaps between. The universe is already humming with the quiet geometry of destiny. You can almost hear it, the low, omnipresent vibration of expansion. Maybe it's not sound in the ordinary sense, but something more like a cosmic pulse, a rhythm that will one day echo in the background radiation, the faint whisper that modern radio telescopes still detect. You wonder if this vibration is the universe's first song, a hymn of pressure and release, of stretching and cooling. If so, it's playing in a key no human ear will ever hear. The physics of inflation sound abstract, but there's something poetic about it too. Space isn't just stretching, it's remembering. Each region carries within it the faint imprint of its origins, the scars of that first cosmic surge. When cosmologists map the sky today, they see these scars in the cosmic microwave background, tiny variations in temperature that mirror the fluctuations from this exact moment. The pattern is ancient, delicate, and astonishingly precise, like the faint marbling on the surface of a seashell that formed billions of years ago. A playful thought crosses your mind. What if this inflation wasn't a one-time event? Some physicists propose that inflation could spark again and again in different regions of the greater multiverse, creating countless bubble universes like ours, each expanding independently. You imagine them, bubbles forming in an endless quantum foam, each with its own laws, its own physics, maybe even its own versions of you. It's a bizarre concept, but then again, so is everything about this era. And somewhere perhaps another bubble is forming right now, unaware that its sibling is sitting here, glowing softly in its own newborn light. By the time inflation ends, after a mere 10 to the negative 32nd seconds, the universe has grown so vast that its visible portion today spans nearly 93 billion light-years. You can't help but marvel at that number. 93 billion light-years of space born from a fraction of a second. The scale is ridiculous. But that's the thing about the universe, it's never been particularly modest. As the inflation slows, the pent-up energy from the inflaton field releases into a burst of particles and radiation, a process cosmologists call reheating. It's as though the universe, having stretched itself into immensity, suddenly fills with light and matter again. The fabric of reality vibrates with newborn energy, setting the stage for the next act. The formation of the first true particles. You take a moment to let it all sink in. You've witnessed space itself stretch from nothing into nearly everything. The inflation has done its job. It's smoothed the universe, seeded its structure, and written the earliest pages of its story. And though you can't see it yet, the next step is coming. The cooling, the condensation, and the birth of the very first bits of matter. For now, though, the expansion continues quietly. The rush of growth is over, replaced by a slow, steady hum. The universe exhales, wide and calm, its glow fading just enough for the next chapter to begin. You drift through the cooling afterglow of inflation, and for the first time, the universe feels less like a storm and more like a simmer. The wild expansion has slowed into something gentler, and space, once tearing itself apart faster than light, now breathes with an almost steady rhythm. The stage is set for a quieter miracle, the birth of matter itself. This is the era physicists call reheating, the moment when the energy that powered inflation transforms into a hot, dense soup of particles. The fireworks are over, but the embers are glowing fiercely, filling the cosmos with the ingredients for everything that will ever exist. You can almost picture it, a vast, luminous fog stretching in all directions, not empty, not yet transparent, but thick with potential. The temperature has dropped to around 10 to the 27th power Kelvin, still far beyond anything humans could ever experience, but cool enough for something extraordinary to happen. The inflaton field, that mysterious driver of cosmic expansion, releases its remaining energy into a flood of radiation and elementary particles. Suddenly space is alive with motion. Quarks, tiny twitching specks, burst into being, zipping through a glowing sea of gluons, They're invisible companions that bind them together. The universe is no longer a blank page. It's more like a pot of cosmic stew, bubbling with ingredients that have only just learned to exist. Everywhere you look, if look even applies, you see collisions, annihilations and rebirths happening trillions of times per second. Particles appear, vanish, and reappear, following the strange quantum rules that have governed reality since the beginning. Energy and matter blur together in a frenzied dance. You can't tell where one ends and the other begins. It's easy to imagine this as chaos, but there's a strange order hiding inside. Physics is quietly enforcing its rules, even now. The strong nuclear force begins to dominate, binding quarks into protons and neutrons. The electromagnetic force crackles, maintaining balance. Gravity tugs faintly, subtle but persistent, as though already planning for the galaxies it will one day sculpt. The weak nuclear force steps in too, making sure particles can transform, decay, and keep the universe dynamic. Each of the four forces, separated during the earliest moments, now finds its role, and the cosmic orchestra finally begins to harmonize. Historians still argue whether this was the point where matter won against its mirror twin, antimatter. For every particle born, an antiparticle appears, a mirror reflection with opposite charge. They collide almost instantly, destroying each other in brilliant flashes of energy. By all logic, the universe should have ended here, reduced to pure radiation. But somehow, an imbalance occurs. For every billion annihilations, one lonely particle survives without a partner. It doesn't sound like much, but those 1 in a billion survivors become the matter that builds everything: stars, planets, coffee cups, and you. Scientists still don't know why matter got this lucky. Maybe a subtle twist in the laws of symmetry, or maybe just cosmic bias. Whatever the reason, existence owes its persistence to that tiny fraction of leftovers. You glide through the dense plasma and feel the energy thrum around you. It's bright beyond description, though the brightness isn't light as you know it. Its radiation so intense it saturates the very fabric of space. The universe, still only a fraction of a second old, is roughly the size of a solar system now, and it hums with power. Photons crash into particles, particles slam into each other, and new forces ripple outward. Every flicker, every vibration, is part of a chain reaction that will echo for billions of years. Here's a quirky historical aside. In the mid-20th century, when scientists first simulated this era, they jokingly called the resulting conditions the quark-gluon plasma party. It's an absurdly energetic soup that humans have actually tried to recreate, briefly, inside particle accelerators like the Large Hadron Collider. When those experiments succeed, even for a trillionth of a second, the detectors light up like tiny universes being born. The scientists cheer, take measurements, and then go for coffee as if they didn't just recreate the first micro-instant of existence. You drift closer to one of these quark swirls, watching as they combine into trios, protons and neutrons forming like tiny clusters of hope in the fire. Each new particle carries with it the potential to build something larger. In just a few minutes, these protons and neutrons will fuse into light atomic nuclei, hydrogen, helium, and a sprinkle of lithium. Those will become the foundation of every future star and every cell that will ever breathe. But for now, they're just forming, fleeting and unstable, in a universe too young to know its destiny. You can almost sense the cooling. The radiation begins to thin slightly, just enough for these first building blocks to survive more than a fraction of a second. The collisions continue, but not quite as violently. Patterns emerge. Fields fluctuate, but within limits. It's like watching the universe take its first deep breath after birth. The chaos isn't gone, but it's calming, finding rhythm in its randomness. And in this rhythm, you notice something else. Time finally feels real. It's measurable now, a steady current flowing from one event to the next. A second actually means something. Space has expanded enough that the intense curvature of gravity no longer distorts the very concept of sequence. You can count again, not that you'd ever catch up, but it's comforting to know the universe finally keeps time with you. You wonder, briefly, what it would feel like to touch this plasma. You wouldn't last even a microsecond, of course, but curiosity is irresistible. The energy would shred your atoms before you could blink, if blinking were a thing yet. But there's a certain beauty in that danger. every explosion, every annihilation, every flash of radiation is a reminder that creation and destruction have always been partners. The universe is built on their dance. Historians like to point out that when early cosmologists described this stage, some thought of it almost spiritually, as a cosmic furnace, forging the materials of being. That metaphor still feels right. You can sense the forging, the relentless compression, the trial by fire that makes permanence possible. Without this burning chaos, there would be no atoms, no chemistry, no chance for consciousness to ever arise and ask, where did it all begin? The temperature continues to drop. What began as an inferno of unimaginable violence is settling into something more structured. Radiation dominates for now, but matter, those stubborn, surviving particles, has planted its flag. The expansion will keep diluting energy, but gravity is patient. It will wait billions of years if it must, until the time comes to pull everything back together. You let yourself float, weightless, inside the flickering glow of the newborn cosmos. Around you, the first particles of creation spin and scatter, like dust motes in a sunbeam that doesn't yet exist. The universe is only minutes old, but it already feels ancient, vast, humming, alive. And somewhere in this fire, the faint blueprint of you is hidden, waiting to cool into reality. You drift onward, deeper into the bright plasma of a universe that is still trying to decide what it wants to be. The wild inflation is long over now, and the furious expansion has calmed into something steady and predictable. Space still stretches in every direction, but no longer in a manic rush. It's a slow, confident stride. You've arrived in an era about 1 second after the Big Bang, when the universe is finally cool enough, around 10 billion degrees Kelvin, for things to start forming patterns that last longer than an instant. You can feel the difference. The density, though still beyond comprehension, is less crushing. The plasma glows with a soft, uniform brilliance, like the inside of a star spread across infinity. Particles and radiation are in constant motion, colliding, fusing, annihilating, but there's rhythm to it now. The universe has moved from chaos to choreography. You're watching energy transform into matter, and matter dissolve back into energy, in an endless balancing act that somehow feels peaceful. This is the moment when quarks, those tiny bundles of possibility, finally begin to settle into stable groups. They pair up in trios, held together by the strong nuclear force, the most powerful of nature's four. Each trio becomes a proton or a neutron, and suddenly the universe is full of the building blocks of atomic nuclei. You watch one of these new particles spin through the haze, glowing faintly as it collides with others. They're fragile, fleeting, but they endure just long enough to make their presence known. And here comes one of those cosmic debates that refuses to die. Historians still argue whether these early seconds represented true balance or the first hint of asymmetry. Because even as protons and neutrons stabilize, their opposites, antiprotons and antineutrons, do too. Matter and antimatter, locked in a violent duet, annihilate each other in showers of pure energy. By all rights, the two should have destroyed themselves completely, leaving nothing behind but radiation. And yet, they don't. For reasons still cloaked in mystery, matter gains the tiniest edge, roughly one extra particle of matter for every billion pairs that vanish. It's the cosmic lottery, and matter wins by a whisper. Without that imperceptible imbalance, the universe would have remained forever sterile, a sea of light with no stars, no planets, no stories. You, a quiet observer adrift in the afterglow, wouldn't even exist to notice. You can feel that imbalance now, subtle but definite, a flicker of permanence amidst the churn of annihilation. The radiation from all that destruction fills the universe, bathing everything in an even, brilliant glow. The temperature begins to drop to about 3 billion degrees Kelvin, and as it cools, new processes emerge. Electrons, zipping around like cosmic fireflies, start interacting more predictably with protons and neutrons. The first light elements, hydrogen, helium, and a whisper of lithium, are beginning to take shape, though not fully formed yet. The universe is preparing for its first act of nuclear alchemy. Here's a fun aside to keep you anchored in the science. This stage is what physicists call baryogenesis, the creation of the baryons, those composite particles like protons and neutrons that make up almost all visible matter. The exact mechanism behind the asymmetry that favoured matter over antimatter, still a mystery. Theorists propose complex ideas involving neutrino behavior or violations of certain symmetries in fundamental laws, but there's no consensus. It's the kind of puzzle that keeps cosmologists awake at night, even though the rest of the universe seems perfectly content with how it turned out. As you float through the radiation bath, you begin to sense a pattern forming in the density of space itself. Small fluctuations, those faint wrinkles seeded during inflation, are growing ever so slightly. In denser regions, gravity tugs a little harder, drawing matter inward. In sparser regions, it releases, allowing energy to expand freely. These subtle differences will grow, slowly but surely, into galaxies and voids. The universe, though still glowing and hot, is already sketching the outlines of its grand architecture. The light around you is blinding, but it's also oddly comforting. It's pure, clean, uniform. A warm blanket of energy stretching across all directions. You realize that this very glow, this light filling every inch of space, will one day cool into what scientists call the cosmic microwave background, the faint radiation that modern telescopes still detect as an echo of this era. You're drifting inside the future's most ancient whisper. A quirky bit of historical trivia floats into your mind. When scientists first detected that background radiation in 1965, they thought it was pigeon droppings on their antenna. Literally. Two radio astronomers, Arno Penzias and Robert Wilson, spent weeks trying to clean a persistent hiss from their equipment, only to realize they'd stumbled onto the oldest sound in the universe, the afterglow of creation itself. Sometimes science begins with a broom and a very confused bird, but back here, in the first few seconds after the Big Bang, the hiss is more like a roar. The radiation pressure is so intense that it keeps matter and light locked together in a turbulent embrace. Photons scatter endlessly, bouncing off charged particles unable to travel freely. The universe is opaque, glowing but impenetrable, a cosmic fog that hides its own depths. It will take nearly 380,000 years before light finally breaks free. For now, you float inside an ocean of brightness that no eye can see. Still, you can sense that something has changed. The fury of creation has given way to endurance. Protons and neutrons, those new building blocks, are everywhere now, and they're starting to clump in small amounts. The universe is expanding, yes, but it's also stabilizing, cooling, finding a sustainable pace. You might say it's entering its toddler phase, messy, loud, and bursting with potential. You drift close to a cluster of these new protons, watching them spin and collide, fusing briefly before the heat rips them apart again. The strong nuclear force holds them for mere moments, a preview of what's to come when the temperature drops just a bit more. The light around you pulses softly, not in waves you can see, but in temperature. Regions slightly warmer, slightly cooler, playing tag across the expanse. The universe hums quietly. It's a hum that feels eternal, resonant, almost peaceful. You can tell that from here on, change will come more slowly. The wild, violent youth of existence is fading, giving way to structure, to stability, to the slow march of time. The elements are being forged and gravity is patiently waiting to sculpt them into something more beautiful. For now, though, you remain in the glow, weightless and warm, surrounded by a light that will echo through eternity. The war between matter and antimatter has ended. The universe, against all odds, has chosen survival. You drift through a sea of light so dense and all-encompassing that there's no shadow anywhere, no edge for darkness to hide behind. The universe has cooled to about 10 million degrees Kelvin, still ferocious by any human standard, but finally cool enough for protons and neutrons to cling together without being instantly torn apart. This is the age of nucleosynthesis, the cosmic workshop where the first true atomic nuclei are born. The light around you isn't gentle yet. It's the sharp, blinding shimmer of creation still underway. But it's less chaotic than before, less desperate. The young universe has settled into a rhythm, the wild symphony of its birth giving way to a steady, determined pulse. You can sense it, protons and neutrons whirling through the dense plasma like dancers searching for partners. Every now and then they collide just right, stick for a breath of time, and fuse. 2 protons and 2 neutrons join hands, forming helium-4. Some lighter helium isotopes, a dash of deuterium, and even a sprinkle of lithium-7 appear as well, and that's it. Those few ingredients will make up almost all ordinary matter in the cosmos forever. Hydrogen, the simplest of all atoms, remains the most abundant. Its patience will later feed the furnaces of stars, but for now it floats freely, unfinished. You watch a pair of protons crash together and release a flash of light. Nuclear fire captured in a single instant. The heat of the surrounding plasma makes you feel like you're inside a star's core. In a way you are. For these brief minutes, the entire universe is a star, its density and temperature perfect for fusion on a cosmic scale. But the clock is ticking. As space expands, the temperature drops rapidly, and in a matter of minutes the fusion window closes forever. The universe, once again, shifts its focus from creation to preservation. Historians still argue whether the early pioneers who predicted this process truly understood its elegance. In the 1940s, a team led by George Gamow and his students Ralph Alpher and Robert Herman calculated how the elements could form in the heat of the Big Bang. Their 1948 paper was meant to include the physicist Hans Bethe as a co-author, purely as a pun: Alpha, Beth, Gamow, like the first three Greek letters, Alpha, Beta, Gamma. Bethe didn't actually contribute to the work, but the authors couldn't resist the joke. It's comforting to know that even when dealing with cosmic origins, scientists still made time for wordplay. The math they developed turned out to be stunningly accurate. You can see it here, unfolding in real time, roughly 75% hydrogen, 25% helium by mass, with trace elements making up the rest. These numbers will remain constant across the observable universe, a fingerprint of its fiery beginning. When future astronomers measure the composition of distant stars and galaxies, they'll find the same ratios echoed everywhere, a quiet confirmation that all matter shares one origin story. Around you, the light begins to soften. As the universe cools past 1 billion degrees, free neutrons start to decay, turning into protons and electrons. The density drops further, and collisions grow rarer. The once blinding plasma dims to a soft golden haze. You imagine yourself standing at the centre of a fading bonfire. The flames are smaller now, the heat still intense, but you can finally breathe. The first real atoms will not appear for hundreds of thousands of years yet, but their skeletons, their nuclei, already drift here, waiting. You realise that in this moment, the universe has built all it can build under its current conditions. Heavier elements like carbon, oxygen, or iron require stable stars to forge them. The Big Bang stops at helium because gravity hasn't yet gathered matter into dense enough pockets for sustained fusion. The cosmic workshop goes quiet, its tools cooling in the dark. From now until the first stars ignite, creation will pause. Still, the residual radiation fills every inch of space. Photons bounce endlessly off charged particles, unable to travel in straight lines. The universe is opaque, a fog of light so thick that vision is meaningless. You move through it like a swimmer through glowing water, every motion stirring ripples of brightness. You can almost feel the temperature fall on your skin, though there is no skin, no air, no sound, only the steady whisper of expansion. And as it cools, something remarkable happens. The universe begins to lose its blinding uniformity. Those tiny fluctuations from the inflationary era, variations in density no bigger than 1 part in 100,000, start to matter. In slightly denser regions, gravity begins to tug harder, pulling atoms together ever so faintly. In slightly thinner regions, matter drifts apart. The seeds of galaxies are being planted invisibly in this glowing soup, patterns so delicate that only billions of years later will they become constellations. A stray thought passes. It's odd how much permanence depends on imbalance. Perfect symmetry would have left nothing behind. Perfect uniformity would have meant no stars, no planets, no one to notice any of this. The universe seems to prefer imperfection. It's through tiny flaws that beauty finds a way to grow. Even now, the smaller symmetries in temperature and density whisper the promise of everything to come. You move with the expansion, carried outward as the light thins. The average energy of the photons drops, their wavelength stretching with space itself. What once was ultraviolet fire becomes infrared glow, then microwaves, then, eventually, radio waves drifting through cosmic silence. That gentle background hum will remain, a record of the first heat fading ever outward. Here's a small quirky note you might appreciate. Modern labs have recreated miniature versions of this early plasma. by colliding gold nuclei at near-light speeds. When the detectors flash, the resulting soup behaves almost exactly as theory predicts. Fluid, nearly frictionless, more perfect than any liquid on Earth. The data from those experiments confirm that the first seconds after the Big Bang weren't chaotic at all. They were exquisitely ordered, governed by simple, elegant laws. Back in the newborn cosmos, the temperature has fallen to about 300 million degrees Kelvin. The great fusion fires sputter out. Protons and electrons still race wildly. But the era of big creation is over for now. The universe has its ingredients. Now it needs time. Time for gravity to sculpt, for cooling to continue, for the first sparks of starlight to eventually ignite. You let yourself float in the fading warmth, surrounded by a fog that glows softly like molten gold. Every proton around you is a survivor of unimaginable heat and violence, and one day, one of them might end up inside a cell, a thought, a heartbeat. It's strange comfort. All of history condensed into these particles, drifting quietly in the calm after the storm. The universe exhales. It has earned its rest. You drift in silence now, through a universe that has, at last, found its pace. The wildfires of creation have dimmed, leaving behind a warm, uniform glow that fills everything. There are no stars yet, no galaxies, only a vast sea of light and hydrogen, an expanse where energy and matter are still indistinguishable companions. It is 380,000 years after the Big Bang, though time feels meaningless here, stretched and soft. You're witnessing the moment the universe learns to let light go free. The temperature has dropped to around 3,000 degrees Kelvin, cool by cosmic standards, roughly the surface heat of a red dwarf star. For the first time, it's low enough for electrons to calm down and cling to protons, forming neutral hydrogen atoms. The plasma fog that once trapped light becomes transparent. Suddenly, photons, those restless messengers, are free to travel across space without constantly crashing into charged particles. The universe, for the first time in its history, becomes visible. This moment is called recombination, though it's really a first combination, electrons joining their partners, light breaking loose. You can feel the change. The glare of radiation softens into a golden mist, then fades to a faint reddish afterglow. The fog lifts. For the first time, space has depth. Shadows could exist now, though there's nothing yet to cast them. The light released in this moment will never stop travelling. It will stretch and fade as the universe expands, cooling into microwaves, becoming the quiet static that fills the gaps between galaxies. Billions of years later, that same light will whisper to radio telescopes, a soft echo scientists call the cosmic microwave background. You float within it as it's born. It's not light you can see, but you can feel it, smooth, even, and calm, like the sound of rain on an infinite roof. The pressure of photons against your awareness feels steady, balanced. This is the first time the cosmos looks uniform on large scales, the same in every direction, with only the tiniest fluctuations in temperature, 1 part in 100,000. Those faint ripples are all that distinguish one region from another, but they're enough. They'll grow into everything. Historians still argue whether the detection of this ancient glow in 1965 truly marked the end of the Big Bang debate. Before that, scientists were split between two rival ideas: the steady-state universe, which had no beginning, and the Big Bang, which began with an explosive event. When Penzias and Wilson stumbled upon that persistent microwave hiss, it was the cosmic tiebreaker. Their find was so accidental, so serendipitous, that it feels poetic. Proof of cosmic origins discovered not through ambition, but through patience with a stubborn bit of noise. You can almost see that hiss now, not as sound, but as pattern. The entire sky glows evenly, but if you look closely enough, the faintest mottling breaks through, like delicate brushstrokes across a golden canvas. Those are the fingerprints of inflation, the quantum wrinkles from the universe's birth now magnified to cosmic scale. In some patches, the light is microscopically warmer, in others slightly cooler. These minute differences in density will decide where galaxies gather, where clusters form, and where vast empty voids will remain. The light travels outward endlessly, redshifting as space expands. Each wave stretches, its colour sliding toward the longer end of the spectrum. The universe, once orange-white with heat, becomes crimson, then infrared, then microwave. The glow dims to invisibility, but it never dies. Even now, in the year 2025, that same light still hums through every room, every sky, every stretch of space between the stars. Every second, billions of those ancient photons pass through you, silent travelers from the dawn of time. You imagine what this universe would look like now if you had eyes that could see all wavelengths at once. It would be hauntingly beautiful, an endless fog of faintly glowing hydrogen, its light smooth and gentle, the same in every direction. No stars, no planets, no galaxies yet, just a uniform sea of warmth. The energy density is dropping, but gravity hasn't given up. Invisible hands begin to tug at the densest regions, pulling gas into filaments and knots. The cosmic web is forming, though it will take hundreds of millions of years before anything visible appears. There's something soothing about this emptiness. It's not lifeless, just waiting. The universe has entered its first true night, the so-called cosmic dark ages. For the next several 100 million years, it will stay this way. No starlight, no fire, just the faint hum of background radiation echoing across growing distances. Space stretches so much that the light softens further, fading into wavelengths your senses could never perceive. But the quiet isn't loneliness, it's gestation. You drift through that newborn transparency, surrounded by atoms that glide silently past each other. There's a faint sense of balance here, a peace that the earlier universe never had. The expansion continues, but calmly. Gravity and dark energy are still in their delicate dance, neither dominating yet. The cosmic background glows behind you like a low ember, spreading outward in every direction, its perfection breathtaking. Here's a quirky thought. If you could somehow fast-forward time and compress the whole sky's microwave glow into visible light, it would resemble the most uniform sunset ever painted. No edges, no shadows, just warmth fading into calm. That light, stretched thinner by eons, would tell the story of everything that happened before. And we, curious creatures billions of years later, would use it as a map to decode our own origins. Even now, you can sense that scientists, tiny beings in one corner of this vast expanse, will one day trace these patterns with exquisite precision. They'll launch satellites like COBE, WMAP, and Planck to measure temperature variations smaller than 1,000th of a degree. They'll convert that ancient radiation into colours and contours, and from those colours, they'll read the history of the universe like braille written in light. But here, where you are, the universe doesn't yet know what science is. It's quiet, content to exist. The great fires are out, the light has escaped its fog, and darkness is spreading softly, gently, like a blanket drawn over the face of a sleeping child. You feel the temperature fall one last time. From 10,000 degrees to 3,000, from 3,000 to 2,000, the glow cools, fading into invisibility. The photons move past you in endless streams, ancient and ageless, carrying the memory of everything that came before. And though you can no longer see them, they're still there, whispering through space, through time, through you. You drift, weightless, between waves of invisible light, surrounded by the universe's first silence. It's not emptiness, it's peace. The glow fades completely now. What was once a radiant ocean has cooled into near darkness, a vast and endless silence stretching across every direction you can imagine, and even directions you can't. The universe has entered what cosmologists poetically call the cosmic dark ages. You drift through the quiet, through hydrogen fog so diffuse it's barely there, through emptiness that feels almost kind. No stars burn, no galaxies yet shimmer. The great cosmic furnace has cooled into a waiting room of infinity. The temperature has fallen to just a few dozen degrees above absolute zero. The photons released during recombination still streak past you, but their wavelengths have stretched into microwaves, too long and too faint to light anything. The universe is expanding steadily, its contents thinning. Hydrogen and helium atoms float like fine mist, perfectly even in all directions. To call it peaceful is an understatement. It's the kind of calm that feels ancient and infinite, the breath between heartbeats before something new begins. But this isn't true emptiness. Gravity is still at work, invisible and relentless. The slight differences in density, the tiny wrinkles left by inflation, are now the only features that matter. In the slightly denser regions, hydrogen gas begins to gather, drawn together by its own faint pull. You can't see it yet, but the first cosmic architecture is forming. Vast filaments of matter stretch across unimaginable distances, weaving what will become the cosmic web, the scaffolding of all future galaxies. You're floating within those invisible threads right now, the quiet blueprints of creation etched across the void. If you could close your eyes and listen, not that sound travels here, you might imagine a low, slow heartbeat in the fabric of space. A rhythm measured not in seconds, but in millions of years. The denser regions throb with the pull of gravity, tightening their invisible grip, while the emptier spaces relax and expand even faster. This push and pull will continue for hundreds of millions of years, until the quiet breaks and the first stars ignite. For now, though, it's pure stillness. A darkness so deep it almost hums. You drift through hydrogen clouds so tenuous that a cubic meter of space contains just a few dozen atoms. Yet on this cosmic scale, even that is enough. Every atom counts. Every bit of matter adds weight to gravity's patient plan. The universe may seem static, but beneath this silence, an intricate story is unfolding molecule by molecule. Historians still argue whether this era should be called dark at all. Some prefer to think of it as the hidden dawn, a time not of absence, but of preparation. After all, the first stars are already gestating invisibly in the densest knots of gas. They won't shine for another 100 million years or so, but their formation has already begun. You're standing, figuratively, at the threshold of starlight. You glance around at the emptiness, and it occurs to you that this dark age is the longest period of calm the universe will ever experience. Once the first stars appear, chaos will return. Radiation, explosions, gravity clashes, black holes, and galaxies colliding. But here, now, there's peace. Space is smooth, time drifts unhurried, and nothing interrupts the flow of expansion. It's almost meditative, as though the universe itself is catching its breath after the violence of its birth. There's a curious side note that modern astronomers like to ponder. During this dark era, the universe was technically glowing, but only in radio waves. If your eyes were tuned to that frequency, you'd see the sky bathed in a soft, uniform glow from all directions, like embers under ash. It's strange to think that even the deepest cosmic darkness still carries a faint warmth, an echo of the first light that refuses to die. You move through the void, past clumps of invisible matter that tug ever so slightly at your path. These clumps are important. They're not made of ordinary atoms like hydrogen or helium, but of something else entirely, something that doesn't emit or absorb light. Dark matter. You can't see it, can't touch it, but its gravity is everywhere. Without it, the gas clouds you're passing through would never gather tightly enough to form stars. Dark matter is the silent architect of structure, the invisible scaffolding holding the universe together. Scientists still have no idea what dark matter truly is. Some think it's made of exotic particles that barely interact with anything else. Others suggest entire classes of objects we haven't imagined yet. Historians still argue whether the concept itself will someday be replaced by something even stranger. Perhaps a new law of gravity we don't yet understand. Whatever the truth, you can feel its presence now, subtle but steady, guiding the invisible web of creation. You pass through a region slightly denser than the rest, a faint concentration of gas and dark matter. Slowly, imperceptibly, gravity begins to squeeze it tighter. The gas heats as it collapses inward, tiny fluctuations turning into currents, eddies, and knots. This is the first step towards something luminous. It will take millions of years for these knots to become dense enough to spark nuclear fusion. But the process has begun. Somewhere, far away, the first protostar flickers faintly into being, hidden behind the thick curtain of hydrogen. You might expect the darkness to feel lonely, but it doesn't. There's something sacred about it, something that feels like waiting for dawn. You know that this is the necessary quiet before the next explosion of light. The universe, in its own patient way, is setting the stage for everything that follows, for galaxies, for planets, for life. Here's a quirky thought to keep your mind awake just a bit longer. If you could time travel to this era and bring along a flashlight, your beam would fade into invisibility almost instantly. The hydrogen atoms around you would absorb and scatter the light before it could go far. You'd be surrounded by darkness again, your flashlight powerless in a world where light doesn't yet have meaning. Still, the quiet persists. The expansion continues. Space cools further, stretching thinner by the moment. Hydrogen and helium continue their slow waltz, drifting gently toward the gravitational wells that will someday birth stars. The darkness isn't an ending, it's an incubation. You float on, weightless and timeless, as the universe dreams of light. The silence deepens, but you know what's coming. Gravity is patient, but it never sleeps. And soon, in just a few 100 million years, the first sparks will appear, the lights that end the long cosmic night. The darkness lasts longer than any night you've ever imagined. Hundreds of millions of years roll by like slow waves, and though nothing seems to happen, everything is quietly preparing. You drift through a universe that's still expanding, still cooling, still mostly hydrogen and helium gas, but the peace you've grown used to is ending. Somewhere deep within the invisible filaments of dark matter, the first knots of ordinary matter are collapsing. Gravity is no longer content to wait. The cosmos is ready for its first sparks of fire. At first you can't see them, not really. The darkness is almost absolute, a black so perfect it swallows even the idea of distance. But faintly, in the densest pockets of gas, something begins to shimmer. Clouds of hydrogen, spanning hundreds of light years, fall inward under their own gravity. As they contract, they heat up. The atoms inside jostle violently, their collisions growing faster, their energy rising. For millions of years, these clouds tighten, fragment, and swirl until, at last, the pressure in their cores becomes unbearable. Then quietly, almost shyly, a first star ignites. It's not a tiny spark. It's a behemoth, hundreds of times more massive than the sun you'll one day know. Its light bursts outward, cutting through the cosmic fog like a torch in a cathedral. You can almost feel the shift. The darkness no longer feels infinite. There's contrast now, places of brightness where once there was only quiet. The first star has lit the first dawn. The cosmic dark ages are ending. You drift closer, watching this newborn sun burn with furious energy. It glows a brilliant blue-white, its surface so hot it would vaporize any known material. The hydrogen in its core fuses into helium, releasing light and heat at a scale no human mind could truly grasp. This first generation of stars, what scientists call population 3 stars, are unlike any that exist today. They're made almost entirely of pure hydrogen and helium, untouched by heavier elements. They burn fast, live briefly, and die spectacularly. Historians still argue whether these first stars formed one at a time or in clusters, whether they blazed alone or in small stellar families. Some theories suggest that the earlier stars were so massive they burned for only a few million years before collapsing into black holes. Others believe they exploded as titanic supernovae, scattering the first heavy elements, carbon, oxygen, iron, into the void. Whatever the truth, you can see the process now. Starlight carving through darkness, radiation ionizing the surrounding hydrogen, reshaping the universe itself. The light from this first generation is fierce. It races outward, colliding with the clouds of neutral hydrogen that once made space opaque. Each photon strips an electron from its atom, rionizing the universe, turning it transparent again. This process, stretching over hundreds of millions of years, is called cosmic rionization, a grand unmasking. The fog that once shrouded creation burns away, and the cosmos begins to glow openly for the first time since the Big Bang. You drift past clusters of these young suns, their light rippling through expanding bubbles of ionized gas. Each bubble grows until it overlaps with its neighbors, forming a vast network of shining regions that connect across the cosmos. From afar, it looks like a web of fire spreading through deep space, each node a cradle of creation. The first galaxies are forming here, small and irregular, like scattered islands of light in an endless sea. You can almost see them swirl, their shapes fragile but determined. Here's a quirky bit of astronomical trivia. When the James Webb Space Telescope peered deep into the early universe, it may have glimpsed galaxies from this very era. Tiny, red-shifted smudges of light that travelled over 13 billion years to reach our eyes. Some astronomers joked that Webb wasn't just looking into the past, it was looking into the universe's baby pictures. And those pictures surprised everyone. Galaxies seemed to form faster and earlier than theory predicted, hinting that the universe was busier in its youth than we ever realized. You approach one of those infant galaxies now. It's small, perhaps only a few thousand light years across, but it's teeming with life in a cosmic sense. Stars form rapidly in bursts, their radiation sculpting the surrounding gas into filaments and voids. Supernovae erupt frequently, each explosion scattering heavy elements into space, enriching the environment for future generations of stars. The first black holes form too, born from the deaths of these massive stars. They begin to feed, devouring nearby gas and growing larger, more powerful. Some will one day sit at the centres of galaxies, shaping everything around them with their gravity. You can almost feel the hum of activity now. The silence of the dark ages has transformed into a cosmic chorus. Light, heat, gravity, and motion intertwining in perfect balance. The universe, once simple and smooth, has become dynamic and textured. From this point onward, complexity will only grow. And yet, even in this burst of brilliance, you notice something familiar. Imperfection remains. Some regions still linger in darkness, too sparse for stars to form. Others collapse too quickly, their light smothered by their own density. But this unevenness is what gives the cosmos its beauty. Galaxies form along filaments, separated by vast, dark voids. It's like a cosmic spiderweb, glittering with dew, fragile, intricate, alive. You drift farther, watching as millions of stars ignite across the young universe. The hydrogen fog fades completely, replaced by glowing clusters, swirling gas, and the faint outlines of spiral motion beginning to emerge. The first constellations, though no eyes yet exist to name them, are taking shape. The long night is over. The temperature of space continues to fall, even as stars burn brightly. Expansion never stops. Every burst of light is stretched thinner with time, its wavelength lengthening as space itself grows. But the light never truly fades. It fills the void, layer upon layer, until the whole cosmos hums with the warmth of starlight. It's hard not to feel a strange affection for this moment. It's the universe's adolescence, awkward, luminous, bursting with potential. You can almost sense it dreaming of what it will become. Galaxies, planets, oceans, and one day, observers who will look back at all this and try to tell the story of where they came from. The first stars burn on, unaware of their importance. Their brief lives end in explosions that send shockwaves rippling through the surrounding gas, triggering new generations of stars. Light begets light, creation feeding on its own ashes. The cosmic dawn is in full bloom now, and you're standing in its glow, the first sunrise of eternity. You drift among the growing brightness, through a universe that is no longer quiet but live with movement. The first stars have burned, lived, and died, and in their short, brilliant lives they've seeded the cosmos with new ingredients: carbon, oxygen, nitrogen, iron. The airless expanse between galaxies now carries traces of these elements, invisible dust motes of possibility that will one day form worlds. The light from billions of young stars washes across your vision, scattering off gas clouds and illuminating the faint outlines of structure. The universe has entered its next great act, the birth of galaxies. You hover within a swirling cloud of gas and dark matter that stretches hundreds of thousands of light years wide. Gravity, ever patient, pulls the material inward, spinning it faster and faster as it contracts. At first, it's an amorphous haze, a storm of hydrogen and helium collapsing in slow motion. But as the cloud spins, it flattens into a disk, and the gas begins to clump into bright knots. These knots are the first clusters of stars, suns bound together by gravity, glowing like lanterns scattered across a cosmic sea. Over millions of years, the disk stabilizes, and a structure begins to emerge. The first true galaxies take shape. They're not the majestic spirals you know from modern telescopes, not yet. These early galaxies are small, chaotic, and full of fire. Their shapes are irregular, lumpy, turbulent, stitched together by collisions and mergers. Every new burst of star formation lights up the surrounding gas, which glows in shades of ultraviolet and blue. Radiation escapes in powerful jets, and supernova explosions ripple outward like thunderclaps, stirring the medium and spreading heavier elements farther into space. The night of the cosmos now blazes with scattered islands of light. Historians still argue whether the earliest galaxies resembled modern dwarfs or entirely new types of structures. Observations by telescopes like Hubble and James Webb show galaxies existing as early as a few 100 million years after the Big Bang, far sooner than many models predicted. Some look like small smudges, dense with hot young stars, while others already hint at spiral arms. The universe, it seems, wasted no time learning elegance. You glide toward one such young galaxy, a radiant cloud of light and dust about 1 billion years old. From a distance, it glows like a candle in fog. Up close, it's chaos incarnate, clouds of gas collapsing into stars while others are blown apart by radiation. The scale is staggering. Hundreds of billions of stars packed into a region that would take light millions of years to cross. The stars swarm around a dark heart, orbiting something unseen, a gravitational monster waiting to be born. And there it is, the first supermassive black hole. Born from the collapse of a colossal star or from the merger of smaller black holes, it now sits quietly at the centre of the galaxy, devouring everything that comes too close. Matter spirals toward it, heating to incredible temperatures before vanishing beyond its event horizon. From the outside, you can't see the hole itself, only the luminous disk of gas swirling around it, glowing fiercely as it falls inward. The radiation it releases is so intense that it can outshine the entire galaxy. Quasars, scientists will call them, cosmic lighthouses blazing from the dawn of time. It's almost funny in a darkly poetic way that the brightest objects in the universe are powered by pure darkness. You can feel the paradox in your bones, if you had bones. Black holes are destruction incarnate, yet without them, galaxies might never have stabilized. Their gravity anchors the chaos, shaping the motion of billions of stars. Even here, in this ancient era, you can sense their influence stretching for light years. A quirky tidbit to lull your thoughts. In the 1960s, when astronomers first detected quasars, they had no idea what they were seeing. Some thought they were nearby stars behaving strangely, while others suggested they were entire galaxies hurtling away at unimaginable speeds. It wasn't until later that scientists realized they were witnessing black holes feasting at the centers of distant galaxies, beacons from the universe's youth. As you move through the young cosmos, the scale of it becomes dizzying. Everywhere you look, galaxies are forming, colliding, merging. It's messy and magnificent, like a cosmic dance where every step creates new possibilities. Some galaxies collide head-on, their stars passing harmlessly through each other, while their gas clouds crash and ignite new waves of starbirth. Others skim past one another, drawn together by gravity, spinning into new shapes. Every collision reshapes the cosmic landscape, turning chaos into beauty. The universe now glows in every direction with the light of billions of stars. From far away you could see the large-scale structure taking form, vast filaments of galaxies stretching across space, intersecting at dense clusters where gravity's pull is strongest. Between these filaments lie immense voids, regions so empty that light can travel for hundreds of millions of years without touching a single atom. The cosmic web has fully emerged, the skeleton of existence revealed, and through all of it, the light from these galaxies races outward, stretching and reddening as the universe expands. You realize that when this light finally reaches distant observers, billions of years in the future, it will carry with it the memory of this moment, preserved in color and energy. Every sunset, every flicker of starlight seen by future civilizations will be a recycled echo of this ancient brilliance. You drift among the growing clusters, watching as new generations of stars form from recycled material, the ashes of their ancestors. The heavier elements forged in those first supernovae mix with hydrogen and helium, giving rise to dust grains, molecules, and eventually chemistry. The cosmos is no longer just a place of light and gravity. It has begun to make ingredients for life. Oxygen for breath, carbon for flesh, iron for blood. You can almost sense the recipe being written in the starlight. The temperature of space between galaxies continues to drop, now just a few degrees above absolute zero. Expansion keeps pulling everything apart, yet galaxies remain gravitationally bound, held close by their own mass. The first large spiral galaxies begin to take shape, their disks flattening, their arms curving gracefully outward. Somewhere in one of these swirls, a small star-forming region glows quietly, unremarkable, ordinary, but destined to become a place of particular importance. For now, though, you linger in the light of the young universe. The stars burn fiercely, the black holes feed, and gravity writes its intricate patterns across space. You can feel that the great act of creation is no longer a single event, but a continuous unfolding. Each explosion, each collapse, each flicker of light part of an unbroken story. The universe is no longer just existing, it's beginning to remember itself. You're gliding now through a universe that has grown comfortable in its own rhythm. The fireworks of first light are behind you, and the cosmos, still young by its own standards, has settled into a grand, expanding tapestry of galaxies. Billions of them drift like glowing islands scattered across an infinite sea, their light stretching and softening as space itself continues to grow. You drift between them, weightless, watching the endless variety, spirals, ellipses, irregular blurs, each one a distinct expression of gravity's patient art. You approach a spiral forming in the distance. It's still a bit rough around the edges, its arms not yet cleanly defined, but you can see the shape emerging. Dust lanes swirl like smoke. Massive blue stars burn in its outskirts, while the dense yellow heart hums with older, steadier suns. You might call it a galaxy, but it's more than that. It's a living system, an ecosystem of stars and gas and dark matter, held together by invisible threads of force. Each orbiting star plays its part, every gravitational tug a note in a song that will play for billions of years. The black holes you met in the previous section still sit quietly at their centres, massive anchors of motion. Around them, glowing disks of gas still feed and flare. The light they release travels for billions of light years in every direction, bright enough to pierce the expanding darkness. You realise that if you could see the universe from outside, these ancient galaxies would look like constellations made of galaxies, clusters glowing at the intersections of the cosmic web. The web itself is breathtaking. Imagine filaments of light stretching across incomprehensible distances, each strand hundreds of millions of light years long. Between them lie enormous voids, regions so empty that they defy belief. In those voids, a handful of atoms might drift through a volume the size of Earth. You glide along one of the filaments, feeling the faint gravitational pull that binds it together. It's like travelling along the nerves of the universe, each connection humming with quiet energy. Historians still argue about how exactly these cosmic structures formed so perfectly. Some say it was all seeded by those faint density fluctuations from the early universe, the wrinkles in the cosmic microwave background that stretched into the vast architecture you see now. Others suggest that dark matter played the primary sculptor, pulling everything into place with a gravity we can't see but can always feel. The debate continues, but you know from this vantage point that it doesn't need to be settled. Both are true. The visible and invisible have always worked together, shaping one another in silence. Here's a small, curious fact to keep your thoughts busy. The Milky Way, your eventual home galaxy, is forming right about now, around 13.2 billion years before your present moment. It begins as a series of smaller protogalactic clouds that merge, collide, and settle into a rotating disk. If you look closely, you can almost see its faint shimmer in the distance, a spiral beginning to take shape amid the chaos. At its heart, a black hole waits, just like in the others, already billions of times the mass of your sun to be. Everything is connected. Even now, the faintest dust that will one day make your bones is already part of that gathering storm. You drift toward one of these merging clusters, and for a moment it's like being inside a slow-motion collision. Two galaxies approach, their edges brushing, their stars mingling. You'd expect catastrophe, but most of the stars glide past one another untouched, separated by enormous gulfs of space. It's the gas and dust that suffer the chaos. Shockwaves ripple through the interstellar clouds, compressing them, triggering new bursts of star formation. The galaxies glow brighter for a while, and then, after millions of years, they settle into a new, larger structure. Destruction and creation, perfectly balanced. It's worth pausing to appreciate that balance. Every act of cosmic violence, every explosion, collision, collapse, is also an act of renewal. The heavy elements forged in dying stars become the seeds for new ones. The gas expelled in supernovae enriches the next generation of planets. Even black holes, those dark engines of annihilation, help regulate growth, preventing galaxies from forming too many stars too quickly. The universe, in its vastness, practices sustainability better than any civilization could dream. You continue gliding between galaxies, your path crossing light that has travelled for hundreds of millions of years to reach you. It's beautiful, but also humbling. Each photon you encounter was born in a star that lived and died long before your world existed. You can feel the passage of time in every hue. The oldest galaxies glow faintly red, their light stretched by expansion. The youngest burst in blue and white, hot and impatient. Space itself carries their stories written in wavelengths and silence. Astronomers will one day spend decades decoding this light. They'll build instruments capable of detecting photons so faint that a candle on the moon would be visible. They'll call this study cosmology, but here, from where you float, it feels more like archaeology. Every beam of light is a fossil, every spectrum a clue. The universe is its own museum, open to anyone patient enough to look. A soft cosmic irony drifts through your thoughts. The faster the universe expands, the lonelier it becomes. The galaxies you see around you now will someday drift so far apart that their light will never reach each other again. From the perspective of future observers, most of the cosmos will vanish beyond a cosmic horizon, unreachable and invisible. The stars of today will fade into isolation, each galaxy a private island in a growing dark. But that's far in the future, billions of years away. For now, the universe is still full of light, still buzzing with the joy of creation. You glance back toward the larger filaments. They look delicate, like spider silk glowing under starlight. Yet each filament holds trillions of suns, tens of thousands of galaxies, countless worlds. The scale is so vast it almost feels absurd, and yet it all obeys the same simple rules. Gravity pulls, expansion stretches, light travels. Out of that simplicity comes this breathtaking complexity. You can't help but smile. If cosmic forces could smile, they'd do it now. Here's another curious tidbit before the scene fades. The universe is already about 4 billion years old at this stage, roughly a third of its current age. By now, life could already be possible in some corners, planets forming around young stars, carbon and water combining into the first simple molecules of biology. It's strange to think that somewhere, in one of these tiny specks of light, chemistry might already be trying to wake up. The view stretches endlessly, galaxies scattered like glowing seeds across a dark field. They drift, collide, reform, cosmic gardeners tending to their own quiet gardens. You sense the inevitability of it all, the flow of energy turning toward ever more intricate forms. The universe hums softly, content, endlessly creative. You drift among galaxies that have grown mature and luminous, each one a whirlpool of stars turning slowly in the dark. The universe is about 9 billion years old now, roughly 2/3 of its current age, and it finally feels settled. The wild violence of its youth has softened into grace. Everywhere you look, spiral arms twist like celestial seashells, elliptical galaxies glow like golden lanterns, and threads of light connect them across gulfs of black. You're watching the cosmos in its prime, the universe bustling with starlight, filled with energy, creativity, and the quiet hum of eternity. At this point, gravity has finished most of its grand sculpting, and the stars themselves have become the primary artists. Deep within their cores, fusion turns hydrogen into helium, helium into carbon, carbon into oxygen and heavier elements. Every heartbeat of a star is an act of creation. The heavier ones burn hot and fast, ending their lives in brilliant supernovae that scatter their contents across space. The smaller ones, quiet, patient, burn slowly, their warmth enduring for trillions of years. The universe now contains all the materials necessary for life, though most of them drift unused in the dark, waiting for the right conditions to come together. You glide past one particularly grand spiral galaxy, its arms gleaming in blues and whites. Near the centre, a dark, invisible weight tugs everything into motion. The same kind of supermassive black hole that sits at the heart of almost every galaxy. These black holes are massive beyond comprehension, millions or even billions of solar masses condensed into a single point. You can feel their gravity warping the space around them, bending light, stretching time. It's strange that the engines of destruction also bring balance to galaxies, regulating star formation and shaping the orbits of entire stellar systems. Without their quiet authority, galaxies might fly apart or collapse entirely. You edge closer to one of these cosmic hearts, watching as a bright disk of gas spirals toward the event horizon. The gas glows in X-rays, hotter than any furnace, brighter than any star. Jets of radiation shoot outward from the poles, stretching for thousands of light years, seeding distant regions with energy. From far away, it looks like a spotlight cutting through infinity. For a brief, breathless moment, you can almost imagine the black hole itself breathing. Inhale, exhale, devour, release. Historians still argue whether black holes destroy information completely or somehow preserve it in ways humans don't yet understand. Stephen Hawking famously proposed that they evaporate over time, leaking faint radiation until they vanish. Others believe that the information of what falls in remains encoded somehow, trapped on the surface like a cosmic tattoo. The debate continues, but from your vantage point you sense that the truth is likely stranger still. The universe rarely wastes anything. Perhaps even the darkness remembers. Around you, the larger cosmic web still stretches outward, but it has thinned. Expansion continues relentlessly. Galaxies move away from one another as the fabric of space grows, the light between them redshifting into lower and lower frequencies. Still, within each galaxy, life goes on. Stars orbit calmly, planets spin, moons glide. There's a rhythm to it now, a steady pulse like a heartbeat at rest. You turn your attention to the smaller details, the gentle flicker of dust illuminated by starlight, the faint glow of nebulae where new suns are being born. Clouds of gas collapse into hot, dense cores, igniting one by one. Every second, millions of new stars flicker to life across the universe. And yet, the overall balance remains. The number of dying stars roughly matches those being born. The cosmos has entered its middle age stable and luminous. A quirky tidbit. Around this era, about 4.6 billion years ago, one modest star forms in the outer spiral arm of a galaxy humans will later call the Milky Way. It's not particularly large or special, but it's stable, a G-type main sequence star, yellow and warm. Around it, leftover dust and gas begin to clump into spheres. Some of these collide, melt and reform, growing larger. One of them, the third from the star, cools enough for liquid water to pool on its surface. If you glance closely, you might even see it, the faint shimmer of blue and white amidst the darkness. You know it, though not yet. You'll call it home. It's strange to think that in the grand scheme of things, the universe barely notices. Stars form and die by the billions. Galaxies collide and merge. Yet here, on one small planet, a new kind of awareness begins. Life. Simple at first, fragile and microscopic, but relentless. Within a few billion years, it will grow curious enough to build telescopes and ask, where did we come from? The same question you're silently floating through now. You let your gaze sweep back across the universe. Galaxies continue to spin, but the spaces between them widen. Light stretches, reddens, cools. The expansion isn't slowing, it's speeding up. Something unseen, something scientists will one day call dark energy, begins to dominate. Its nature is mysterious, a kind of anti-gravity pushing everything apart. Some cosmologists think it's a property of space itself, others that it's a new kind of energy field. Historians still argue whether it will remain constant or change over time, whether it will one day rip galaxies apart atom by atom. But for now, it's gentle. A slow widening, a cosmic sigh. You notice that the background radiation has cooled even further, now just a few degrees above absolute zero. It still fills all of space, the faint afterglow of the Big Bang stretched nearly beyond detection. You think back to when that same light blazed hot enough to blind, when space itself was an ocean of fire. Now it's a whisper, but it's still there, still speaking. The universe remembers everything. You drift through a galactic cluster, where hundreds of galaxies shine together like jewels in a crown. Some are merging, their arms tangled, others drift serenely apart. The space between them glows faintly with X-rays from hot gas, trapped in the cluster's deep gravitational well. It's a reminder that even emptiness holds structure, that even the void has stories to tell. You can feel the pace of the universe slowing around you, not in its expansion, but in its energy. The most massive stars have burned out, leaving behind neutron stars and black holes. The smaller stars endure, but they're quieter now. The brilliant blue-white light of youth has softened into the steady gold of maturity. The cosmos hums in deeper tones, its energy shifting toward the infrared. It feels calm, aged, wise. And as you drift, the scale of everything becomes almost too much to grasp. From the tiniest particles in the hearts of stars to the largest clusters of galaxies, everything follows the same pattern: creation, transformation, decay, renewal. The cycle continues endlessly, without preference, without pause. The universe has no hurry. It will keep unfolding long after every human story has ended, long after even memory itself fades. You exhale, if breathing were possible here, and let the enormity of it wash over you. Light, gravity, matter, time. All of it woven together into one seamless fabric. You can almost hear the universe sigh in contentment, its long history stretching ahead into eternity. The stars pulse softly, the galaxies drift farther apart, and the cosmic hum grows quieter. You can feel the great story easing toward its slower chapters. But for now, there's still warmth, still light, still motion. The universe is alive, dreaming in slow, endless patterns. You linger in the soft glow of that middle-aged universe, and though everything around you still sparkles, you begin to sense an invisible shift, a quiet acceleration that no one living inside these galaxies could feel. Space itself is stretching faster than before. The universe, after billions of years of coasting, has changed its rhythm. Expansion, once slowing under the pull of gravity, is now quickening again, as though some hidden force has pressed gently on the gas pedal of existence. This mysterious influence is what scientists with charming humility call dark energy. You can't see dark energy, can't feel it, can't measure it directly, but you can see what it does. The galaxies that once drifted apart at a steady pace are now slipping away faster and faster. Their light stretches redder as it travels, the wavelengths lengthening like sighs through the vacuum. From your position among the filaments of the cosmic web, it's subtle at first, just a hint of extra distance between the glowing clusters. But over time it becomes unmistakable. Space is not just expanding, it's accelerating. The universe is learning to let go of itself. You drift through a supercluster, one of the last great gatherings of galaxies that will remain gravitationally bound. Within it, thousands of galaxies whirl together in a slow, majestic dance. Beyond its borders, though, everything is moving away, faster and faster, slipping beyond the reach of gravity's long arms. One day, far in the future, observers in any single cluster will see only their own neighbours. The rest of the cosmos will fade beyond visibility, its light stretched into oblivion. The universe is turning inward, not by collapse, but by distance. Historians still argue whether Einstein's greatest blunder was a blunder at all. When he first formulated his equations of general relativity, he inserted a constant, a mathematical patch, to counteract the natural tendency of gravity to collapse the universe. He assumed the cosmos was static, unchanging. Later, when Hubble discovered that galaxies were actually receding from one another, Einstein dropped the constant, embarrassed. Yet decades later, scientists discovered that the universe does have a repulsive component after all. Dark energy behaves almost exactly like that constant, an invisible pressure woven into space itself. If Einstein could see this now, he might laugh softly and say, "So perhaps it wasn't a mistake after all." You move farther out, watching galaxies blur as distance warps perception. Their light, stretched by the accelerating expansion, reddens until it slips beyond visible wavelengths. First the blues fade, then the whites, then even the deep crimsons melt into infrared. To human eyes, the cosmos would appear to dim, but it's not the light that's changing, it's space itself, pulling that light apart as it travels. The universe is literally writing itself thinner, turning colour into silence. Here's a quirky detail worth noting. Modern astronomers measure this acceleration using what they call Type Ia supernovae, exploding stars that always reach the same intrinsic brightness. By comparing their observed brightness to their expected brightness, scientists can determine how far away they are and how fast they're receding. It was in the late 1990s, when two independent teams compared these distances, that they realized the unimaginable. Galaxies weren't just moving away, they were speeding up. The discovery was so unexpected that even the scientists who made it thought they'd miscalculated. But the math held, and with it, a new era of cosmology began. As you drift, the acceleration feels eerie. The spaces between galaxy clusters stretch wider. The once continuous web of matter begins to thin, its threads tugged apart. Galaxies that were once neighbours now recede faster than their light can cross the gap between them. You sense the growing loneliness of the cosmos, a kind of cosmic isolation written into the laws of physics themselves. Still, there's beauty in it. Expansion means freedom. Every region of space becomes its own small universe, complete and self-contained. You think of the galaxies that will remain bound, the local group where the Milky Way and Andromeda reside, for instance. In about 4 billion years, those two will collide, merging into a single, larger elliptical galaxy. From inside, future observers will see only their own stars, never guessing that beyond their galactic horizon, trillions of others once existed. The visible universe will shrink not because it's collapsing, but because the rest is slipping away faster than information can travel. The irony is exquisite. The larger the universe grows, the less of it anyone will be able to see. But even now, with expansion accelerating, the night sky remains full of light. The Milky Way still spins, its arms sweeping gracefully through the dark. Stars continue to form, burn, and die, each one a spark in the slow furnace of time. You float above one of its arms, looking down on the familiar pattern of dust lanes and glowing nebulae. The sun burns steadily, barely middle-aged, its planets tracing calm orbits. On the third one, faint and blue, life flourishes, unaware that it exists inside an accelerating universe. From here, you can see it all at once. Galactic majesty and quiet domestic detail, the macro and the micro coexisting effortlessly. Dark energy hums beneath it all, subtle but omnipresent. It doesn't roar like gravity or flare like fusion. It's more like pressure without direction, the soft tension of the vacuum itself. Some physicists describe it as an inherent property of space, every cubic meter of emptiness carrying a tiny, constant amount of energy. Others suspect it's something even stranger, perhaps the effect of quantum fields fluctuating in the void. There's also a fringe idea that dark energy might change over time, like a cosmic tide that could one day ebb or surge. Historians still argue whether that would end the universe in slow coldness or sudden violence. You drift through that tension, feeling the quiet contest between gravity and expansion. Gravity clings, pulling matter into galaxies, stars, and planets. Dark energy pushes, stretching everything apart. For now, they're balanced in a delicate truce, each shaping the other's story. The universe doesn't feel conflicted, though. It feels content, like an old painter who knows that every stroke, even those that seem contradictory, serves the final composition. And as you continue drifting, you notice how the light changes. The starlight has softened from white to amber, the background glow dimming toward invisibility. Expansion continues, silent and unstoppable. The spaces widen, the energy diffuses, but the structure remains, at least for now. The galaxies that still share bonds will keep spinning, stars will keep shining, and life, in at least one corner, will keep wondering. It's comforting to think that even in this era of acceleration, creation hasn't truly ended. It's just taking on a slower rhythm. The universe, after all, doesn't rush. It expands, it cools, it drifts toward equilibrium with infinite patience. You could almost call it serene. You've travelled far enough now that the familiar glow of the galaxies behind you has faded into faint embers, and yet the universe still hums with possibility. The expansion continues, each moment stretching the fabric of space itself. But as you glide through the darkness, you find yourself nearing the boundary of knowledge, the edge of speculation, where science begins to dream out loud. You're entering the realm of theory, of the maybe real and maybe not. This is where cosmologists whisper about the multiverse. Imagine for a moment that the Big Bang wasn't a unique event. Imagine it as one bubble in an endless cosmic foam, a single universe inflating within a vast sea of others. Each bubble expands, just like ours did, but perhaps with different rules, different forces, different kinds of light, or none at all. Some might last only a heartbeat before collapsing back into nothingness. Others might swell eternally, spawning more universes like branches sprouting from the trunk of an infinite tree. You drift through this thought as if through mist, a multiverse not of science fiction, but of serious mathematics. It's not an idea born of fantasy, but one that grew naturally from physics itself. The equations describing cosmic inflation, the same mechanism that smoothed our own universe after the Big Bang, suggest that inflation might not end everywhere at once. Some regions stop inflating, forming universes like ours, while others continue, birthing new universes endlessly. This is eternal inflation, a theory proposing that creation never truly stops. It just moves on to the next bubble. It's the cosmos playing a never-ending game of expansion, a fractal blooming of reality. Historians still argue whether this concept counts as science at all. Some physicists adore it for its elegance, its ability to explain why the constants of nature, the strength of gravity, the charge of the electron, the speed of light, seem so perfectly tuned for life. In a multiverse, our universe's properties aren't special. They're just one set of dice rolls among countless others. Others, though, find it unsettling. How can you test a theory that describes realms you can never observe? It's a debate that sits right at the boundary between cosmology and philosophy, between measurement and imagination. You drift farther into thought trying to picture what another universe might look like. Perhaps some are colder, expanding so quickly that stars never form. Others might have gravity too strong, collapsing back into black holes before light even has time to escape. Maybe there are universes with no atoms at all, where the very notion of matter doesn't exist. Or perhaps, if you're feeling particularly mischievous, there's another version of you floating through another void, watching a slightly different story unfold. Maybe their universe is younger or older, or tilted at a different mathematical angle. The thought is dizzying and oddly comforting. There's a quirky historical note buried in this chaos of ideas. One of the earliest people to imagine a multiverse wasn't a modern physicist, but an ancient philosopher. Around 400 BCE, the Greek thinker Democritus speculated that there might be innumerable worlds, some larger, some smaller, scattered across infinity. He knew nothing of inflation or quantum fields, of course, but the instinct was the same, a suspicion that existence might be too big for just one version. It's funny how certain thoughts echo through time, waiting millennia for the math to catch up. You pass through the imagined edge of our own universe, the cosmic horizon, the farthest distance from which light has had time to reach us since the Big Bang. Beyond this, there may be more of our universe, or something else entirely. The laws of physics as we know them fade into uncertainty. Here, space might still be inflating, still spawning new regions, unreachable and invisible. You try to picture it, bubbles within bubbles, each expanding into its own reality, each one containing its own version of everything. It's like a symphony of universes, each playing in a different key, never quite overlapping. And yet, even here, where science stumbles and imagination takes over, the same patterns hold. Every bubble has energy, every space has geometry. Even in the wildest corners of theory, the same deep logic hums beneath it all. It's as if the universes, share a common handwriting, a single mathematical rhythm that underlies them all. You can feel that hum now, steady and eternal, a lullaby written in physics. You wonder what this means for the idea of beginnings. If universes can spawn from one another indefinitely, was there ever truly a first? Or is creation just a chain without an anchor, stretching backward forever? Some physicists suspect that time itself might be cyclical, that universes expand, collapse, and give birth to new ones in endless succession. The ancient Hindu texts called it the breath of Brahma, a cosmic inhale and exhale. Now quantum cosmology whispers something similar, that perhaps the Big Bang wasn't the beginning, but the latest heartbeat in an infinite pulse. Of course, no one knows for sure. That's the part that makes this chapter of the story both thrilling and maddening. The universe doesn't give easy answers, it prefers riddles. And maybe that's its way of keeping us curious. Even now, billions of years after its birth, the cosmos continues to surprise the minds that study it. Every time we think we've mapped its limits, it stretches again, offering a glimpse of something stranger just beyond reach. You glance back toward the familiar galaxies, now faint and distant. They seem small against the possibility of infinite others. Yet somehow that smallness feels right. A single universe, rich enough to contain love, thought, and curiosity, doesn't need to be the only one to be meaningful. Its very existence is miracle enough. The light of distant stars flickers gently, red-shifted and soft. You let yourself float in the uncertainty, the beauty of not knowing. Theories rise and fall, but the wonder remains constant. Maybe there are infinite universes. Maybe this one stands alone. Either way, you're here, in a moment, in a cosmos, in the slow heartbeat of something too vast to name. You take a slow breath, though there's no air. The silence feels deeper now, almost reverent. The multiverse hums beyond your reach, and you smile at the thought that even infinity might have room for imagination. You drift slowly back toward familiarity, leaving the speculative fog of endless universes behind, and focus once more on this one, the single bubble that matters to you now. It's easy to lose track of scale when you've been thinking in infinities, but here, in your home cosmos, the evidence of everything that came before still shines faintly. The universe has left fingerprints everywhere, and tonight you're going to trace them. This is where human eyes, patient and curious, start to read the story of creation written across the sky. You begin with light, because light is memory. Every star, every galaxy, every particle that's ever emitted a photon has contributed to a grand cosmic archive. When astronomers point their telescopes outward, they're not just looking through distance, they're looking back through time. The farther you look, the older the light. Galaxies billions of light years away show up as they were billions of years ago. It's like watching a movie where the first scenes play on the edge of sight, and every photon is a frame in the cosmic film. One of the most astonishing discoveries in all of science came from this simple idea, that light stretches as space expands. Edwin Hubble noticed in the 1920s that distant galaxies appeared redder than they should. Their light waves were literally elongated by the expanding universe, a phenomenon we now call redshift. The farther away a galaxy is, the faster it recedes, and the more its light is stretched. This observation was the key that unlocked the realization that the universe is not static but dynamic, growing, moving, breathing. Historians still argue whether Hubble fully understood the depth of what he'd found, or whether it took later generations to grasp the enormity of it. Either way, that faint stretching of colour changed how humanity saw everything. You imagine standing beside Hubble at Mount Wilson Observatory, peering through his telescope into the crisp California night. The air is thin, the machinery hums softly, and in the eyepiece faint smudges of light shimmer against the black. They look like stars, but they're galaxies, entire universes of their own rushing away. Each one is a messenger from the deep past. Hubble's quiet wonder mirrors your own now, drifting out here among those same galaxies, seeing them as he once did, but from the other side of time. Light, though, isn't the only witness. The universe carries more subtle records too, tiny whispers of its own structure written in temperature and radiation. The cosmic microwave background you passed through earlier still hums faintly across every direction. Modern telescopes like COBE, WMAP, and Planck have mapped it in exquisite detail, detecting variations in temperature as small as 1 part in 100,000. Those ripples match perfectly with the density fluctuations that eventually became galaxies. It's as though the universe left behind a baby photo, grainy, warm, and perfectly honest. A quirky little historical anecdote adds charm to that story. When Penzias and Wilson first detected that strange hiss of microwave noise in 1965, they weren't trying to find the Big Bang's echo at all. They were calibrating a new radio antenna for Bell Labs and thought pigeons nesting inside had fouled it up. They spent days cleaning it, scraping droppings, and still the hiss remained. It took a conversation with a Princeton physicist to reveal the truth. They'd accidentally stumbled on the oldest light in existence. Their discovery, quite literally, began with bird poop and ended with a Nobel Prize. You glide now past one of those microwave photons, a relic of the time when the universe was only 380,000 years old. It brushes against you, faint and cold, its wavelength stretched by billions of years of expansion. It's the oldest traveller imaginable, and it still carries the warmth of its birthplace. You realise that every time humanity tunes a radio between stations, that faint static, 1% of it anyway, is this very light. A whisper from creation, still echoing in living rooms and car stereos. From the background radiation to the redshift of galaxies, every observation confirms the same story. The universe has been expanding from a hotter, denser past. But the beauty lies in how humans figured this out, not just by looking, but by measuring. The cosmic detective work has spanned generations. Astronomers use standard candles, objects of known brightness, to measure distance. They use spectral lines to decode composition. They time supernovae, chart galaxy distributions, and simulate the growth of cosmic structures on supercomputers that hum like modern oracles. You can almost hear those machines working now, a low, rhythmic vibration, like the heartbeat of understanding itself. On their screens, galaxies swirl into being from equations. Dark matter weaves its scaffolding, and dark energy pushes everything apart. The simulations play back the story you've been drifting through, step by step, from that first flicker of the Big Bang to the glittering universe of today. Every pixel, every particle, a testament to how far human curiosity has come. Historians still argue whether our picture of the cosmos is complete. Probably not. Every answer opens new questions. What came before inflation? What is dark matter really made of? Will dark energy remain constant, or will it one day surge, tearing the fabric of space-time apart? Yet there's something reassuring in that incompleteness. The universe leaves space for wonder. The edges of knowledge glow faintly, always just beyond reach. You pause for a moment and look back over your shoulder, not literally, but with the kind of inward glance that comes from awe. You've travelled from nothingness to light, from chaos to stars, from theory to memory. Every stage of the journey has left evidence, footprints, and clues scattered across the cosmos. You realise that to study the universe is to read a diary written in radiation and gravity. Humans, small as they are, have learned to translate its ancient script. You let that realisation settle into you, warm and deep. The story of the cosmos isn't locked away in textbooks or telescopes. It's in the starlight itself, in the faint hum of background radiation that slips quietly through every room on Earth. The universe is always telling its story. It just speaks slowly, across billions of years. And as you continue drifting, that slow voice follows you like a song. Light stretched to red, time stretched to patience, the past stretched into the present. You realise that knowing how we know is just as wondrous as knowing what we know. Every photon that's ever reached an eye, every wavelength ever measured, is another whisper in a cosmic lullaby that's been playing since the beginning. You close your metaphorical eyes, letting that lullaby wash over you, a hum of knowledge, discovery, and deep time memory. You've seen the universe reveal itself, one photon at a time, and it's still not done speaking. You linger now, hovering in a present-day cosmos filled with the calm confidence of maturity. The great expansion continues, galaxies wheel quietly in their courses, and the light of countless suns still paints the darkness with colour. Yet, even as the story feels settled, you can't help but think of the theories that almost told it right. The cosmic what-ifs that once held centre stage before giving way to the Big Bang. Because history, like the universe, doesn't unfold in a straight line. It swirls, it collides, it evolves. To understand how we arrived at this story, you have to drift back through the minds of those who tried to explain the stars before we knew what they really were. Long before Big Bang entered the lexicon, most scientists believed in a cosmos that simply was. Eternal, changeless, infinite. That idea fit both philosophical comfort and human intuition. After all, when you look up at the night sky, nothing seems to change. In 1917, Albert Einstein's own equations of general relativity suggested that gravity would make the universe collapse under its own weight, so he added a fudge factor, a cosmological constant to hold everything in place. The steady, unmoving universe seemed a tidy solution. Historians still argue whether he truly believed it, or merely feared the alternative, a universe that moves. But then, in the 1920s, a Belgian priest and physicist named Georges Lemaitre quietly broke the silence. He proposed that the universe began as a single, primeval atom, which exploded outward to form everything we see. His contemporaries smiled politely. The idea seemed absurd, too religious, too metaphorical. And when Fred Hoyle, one of Lemaitre's intellectual opponents, derisively called it this Big Bang idea during a 1949 BBC broadcast, the name stuck. Irony is the universe's favourite joke. For decades afterward, the Big Bang and the steady-state theory battled for dominance. The steady-state model, championed by Hoyle, Hermann Bondi and Thomas Gold, argued that as the universe expanded, new matter constantly appeared to fill the gaps, keeping density constant. No beginning, no end, no cosmic birth trauma, just endless, serene creation. It had a philosophical elegance that appealed to mid-century scientists who still wanted the universe to be eternal. A cosmos without origin conveniently sidestepped any uncomfortable questions about what or who might have lit the first fuse. The debate raged across observatories and lecture halls for nearly 20 years. Both theories explained some data, both failed to explain others. The turning point came, of course, with the accidental discovery of the cosmic microwave background, the faint afterglow of the Big Bang. That single hiss of radiation silenced the steady-state camp almost overnight. The steady-state model couldn't account for a universe still glowing with the warmth of its birth. By the early 1970s, the scientific consensus had shifted, and the Big Bang became not just a hypothesis, but the foundation of modern cosmology. Still, the almost didn't disappear. Other models lingered in the wings, ideas both bold and bizarre. Some scientists proposed plasma cosmology, where enormous magnetic fields shaped the universe rather than gravity. Others revived the notion of a cyclic cosmos, endlessly expanding and contracting, breathing like a living thing. In the 1980s, the theory of inflation entered the stage, explaining how the universe could expand faster than light for a moment, smoothing out irregularities and seeding the patterns we see today. And beyond that came speculations about bouncing universes, bubble universes, simulated universes, each theory its own attempt to make sense of the same luminous evidence. A quirky historical detail: when the first computer simulations of cosmic structure were run in the 1980s, they had so little processing power that scientists sometimes programmed them by hand overnight, then printed results on reams of dot matrix paper. Those simulations, tiny by today's standards, already showed the web-like clustering of galaxies we now observe. Even with primitive tools, the underlying truth refused to hide. You float above a spiral galaxy as you think about this lineage of ideas. The starlight beneath you feels like testimony, each flicker a reminder that understanding doesn't arrive all at once. It's built layer by layer, through centuries of questions and revisions. Every discarded model, every failed theory, becomes scaffolding for the next revelation. The steady-state theory may have lost the fight, but its mathematical elegance inspired methods that are still used to model expansion today. Even Hoyle, the man who mocked the Big Bang, made crucial contributions to nuclear astrophysics. The universe forgives irony as easily as it creates it. You can almost hear the voices of those early cosmologists arguing across decades of time, their equations like overlapping musical themes. Lemaitre whispering of a beginning, Hoyle countering with eternity, Einstein tweaking constants, Hubble stretching wavelengths. Theirs was a symphony of intellect, sometimes harmonious, sometimes discordant, but always guided by curiosity. You drift through their legacy like a ghost at rehearsal, hearing fragments of insight swirl around you. It's humbling, realizing that knowledge is never static. The Big Bang, for all its success, might someday yield to an even deeper understanding. Some new measurement, some quantum twist of space-time could rewrite the story yet again. And that's okay. Science isn't a monument, it's a river. Theories are stepping stones, not temples. You gaze outward again, at a universe both ancient and newborn. It's strange to think that every flicker of understanding humanity has ever achieved came from this single vantage point, a small planet circling an ordinary star. From there, humans deciphered the geometry of space-time, measured the age of the cosmos, even traced the faint hiss of its first light. The sheer audacity of it makes you smile. Historians still argue whether we'll ever reach a final theory, a complete description of reality that ends the chase. But you sense that even if such a theory exists, it won't stop the questions. It will only make them deeper. The universe, after all, thrives on curiosity. That might be its truest constant. You let the galaxies below fade into a soft blur, their light mingling like candle flames in a draftless room. The story of cosmic theory, like the universe itself, is one of expansion, of ideas reaching outward, overlapping, colliding, and creating something new. The steady state, the plasma, the bounce. They all burn quietly here, absorbed into the larger glow of understanding. You exhale into the vastness, not to release air, but to mirror the rhythm of the cosmos itself. Expansion, rest, renewal. Every theory, every discovery, every gaze through a telescope is another breath in that long, patient cycle of knowing. The story of the Big Bang isn't finished, and maybe that's what keeps it beautiful. You float through a universe that is now old but not yet ancient, a place that has exchanged its youthful fire for a steady, measured calm. The great cosmic web stretches wider than ever, its filaments glowing faintly with the light of billions of galaxies. Though from your vantage point the brightness has softened into a diffuse golden haze, time has slowed its visible drama. The stars still shine, the galaxies still drift, but the tempo of creation has eased. You can sense that the universe has entered one of its quieter chapters, and the questions that rise now are not about where it came from, but about where it's going. The expansion, powered by dark energy, continues relentlessly. Galaxies move apart, their mutual gravity weakening as the distances grow. The light between them stretches farther and redder until even the nearest clusters begin to fade from one another's sight. The universe, once so intimate and crowded, is becoming lonely. If you could fast forward billions of years, you'd see the filaments thin like threads dissolving in water. What was once a bright network will one day look sparse, then empty. That's not tragedy. It's entropy doing what entropy does, spreading energy evenly, smoothing everything toward calm. Historians still argue whether this trend means the universe is heading for heat death, a slow drift toward uniform cold, or whether something stranger might await. Some cosmologists favour the Big Rip scenario, where dark energy's repulsive force strengthens over time, tearing galaxies, stars, planets, and eventually atoms themselves apart. Others suggest a more cyclical fate, a big crunch, where gravity might one day overcome the expansion and pull everything back together. Each outcome is both horrifying and oddly poetic, one ending in infinite stillness, another in rebirth through collapse. For now, though, the cosmos seems to prefer subtlety. You drift past a cluster where galaxies are merging in slow motion, their spiral arms weaving together into glowing knots. The collisions are gentle by cosmic standards. Stars rarely hit, but their gravitational fields twist one another into new shapes. Gas clouds compress, birthing new generations of stars that shine briefly before fading again. Even in an aging universe, creation persists. You realize that endings and beginnings are not opposites here. They are the same act viewed from different scales. There's something meditative about the way the universe approaches its decline. Stars like the sun, too light to explode in fury, swell into red giants before shedding their outer layers, leaving behind white dwarfs, hot, dense cores that cool for eternity. The more massive ones die spectacularly, collapsing into neutron stars or black holes. Across the galaxies, this slow transformation repeats billions of times, a quiet choreography of death and renewal. The starlight dims, but it doesn't disappear. It just changes wavelength, sliding toward infrared, then microwave, then radio. The light that once blazed fierce blue now hums as soft warmth between the stars. A quirky aside, in a far future epoch, long after any human calendar has dissolved, the night sky will look radically different. The Milky Way and Andromeda, long since merged into a single elliptical galaxy, some call it Milkomeda, will dominate the heavens. But beyond that, the rest of the universe will vanish from view. All external galaxies will have redshifted beyond detection. To future astronomers born in that time, the universe will appear static again, eternal and unchanging, much like it did to thinkers before Hubble. History, it seems, has a sense of humour. You drift closer to the outskirts of Milkomeda, where aging stars flicker in shades of orange and red. Many have already become white dwarfs, faint embers cooling in silence. Around them, planetary systems remain, barren worlds circling dead suns, their surfaces locked in eternal night. Yet even here, there's beauty. The glow of dying stars reflects off frozen moons, painting them in pale blues and silvers. The cosmic stillness feels less like death and more like deep sleep. You sense the slow arithmetic of entropy at work. The universe seeks equilibrium, the spreading of energy until no gradients remain, no motion, no work. It's not a conscious desire, just the inevitable outcome of thermodynamics. The total energy remains constant, but its usefulness drains away. Over unimaginable spans of time, even the last stars will exhaust their fuel, and the black holes that now punctuate the cosmos will begin to evaporate through Hawking radiation, releasing their mass as faint whispers of heat. The glow of everything will fade into the long twilight of physics. Historians of the far future, if there are any, will have nothing to study but background. The galaxies will be invisible, the starlight gone, the radiation cooled to uniformity. It sounds bleak, but there's something profoundly graceful in it too. The universe began in fire and it will end in silence. The symmetry feels right. Some theorists imagine that this silence won't last forever, that fluctuations in quantum fields could spark new bubbles of space-time, birthing new universes just as ours was born. In that vision, heat death is not a finale but an intermission, a pause before another explosion of light and time. Maybe every universe must fade so that another can bloom. You find comfort in that possibility, not because it promises survival, but because it suggests continuity. Nothing truly wasted, only transformed. As you float through the dimming cosmos, you can almost hear the hum of entropy itself, a long, descending note fading toward quiet. The galaxies shimmer faintly around you, their light stretched and thinned, their voices soft. Time moves differently here, less like a river and more like a deep ocean current, slow and inevitable. You realize that the universe isn't rushing toward its fate, it's gliding there with elegance. Here's a gentle, almost whimsical thought to hold on to. Somewhere in this cooling expanse, a lonely civilization might one day light a final fire, using the last reserves of energy to warm itself against the infinite cold. They might look up at their fading stars and tell stories about the dawn of everything, the way you're watching the dusk of it now. They might call it tragic. You would call it poetic symmetry. You linger in that image, a cosmos slowly dimming, not destroyed but fulfilled. The expansion goes on, but its urgency is gone. The universe has learned patience. Every star that ever lived has given its light to the dark, and the dark in turn carries that light forever, stretched thin across infinity. You take a slow, imaginary breath and let it out, feeling the stillness settle. The fate of the universe may be sealed, but the calm of its long decline is strangely soothing. This is not the violence of collapse, but the peace of completion. The cosmos began with a bang, but it will end softly with a whisper. You hover at the edge of time's slow unravelling, surrounded by the dim shimmer of an aging universe that no longer remembers its own youth. The stars are fewer now, their light sparse and mellow, like the glow of embers long after the fire has burned down. The great cosmic dance has quieted, and what remains is rhythm, gentle, deliberate, eternal. In this silence, you begin to think about what all of this has meant, what the universe's long story says about the small, curious beings who once looked up at its sky and asked, how did it all begin? For billions of years, humans studied this universe from their tiny perch on a blue planet orbiting an ordinary star. They measured the faint radiation of the Big Bang, mapped the positions of galaxies, and built machines so sensitive they could detect the whispers of colliding black holes from billions of light years away. Every discovery brought them closer to understanding, yet never close enough to finish the sentence. The universe kept its poetry intact by refusing to give a final line. You can feel their curiosity still, echoing in the cold, an inheritance that outlived the species that birthed it. You drift toward the remains of the Milky Way, now long merged with Andromeda and countless smaller galaxies. It has settled into an immense elliptical shape, glowing faintly with the light of ancient red stars. The spiral arms are gone, erased by time and gravity. The central black hole still spins quietly at the core, vast beyond imagining, a monument to everything that once was. Around it, old stars move like thoughts, orbiting memory. This galaxy is home to no civilizations now, no signals, no songs, just the calm hum of physics at rest. And yet, there's grace in its stillness. It stands as proof that chaos, given enough time, finds its way to equilibrium. Historians, if they could exist here, would still argue whether humanity's understanding of the cosmos ever reached completion. Some might say it did, that by mapping background radiation, Calculating the universe's age and measuring its expansion, they had solved the puzzle. Others might insist the puzzle was never meant to be solved, only experienced. The truth likely lies somewhere between. The universe, in its complexity, was not a riddle to answer, but a relationship to cultivate. To understand it was to participate in it, to feel awe as an act of knowledge. You drift past the remnants of solar systems, dead suns orbited by cold, crystalline planets. Some are cracked and hollow, others sheathed in ice that glints faintly in starlight. One resembles Earth, though the seas have frozen into mirrors, the continents buried under kilometers of frost. The air is gone, the sky black. But even here, in the emptiness, the atoms that once formed oceans, forests and cities still exist. They've only changed shape, folded back into the universe's patient recycling. Every carbon atom that ever lived in a human body still spins somewhere, part of the cosmic dust that drifts forever between stars. Here's a tender, almost humorous truth. The atoms in your own body, the ones that made your bones and thoughts, were forged in the hearts of ancient stars billions of years before you were born. When those stars exploded, they scattered their contents across the cosmos, and some of that debris eventually gathered into a small planet orbiting a modest sun. So when people said, "We are made of stardust," it wasn't poetry, it was chemistry. You can feel that chemistry now, echoing across time. The same iron, the same carbon, the same oxygen, endlessly cycling through existence. The universe, it seems, has always preferred to reuse its best ideas. Far off in the darkness, you glimpse the faint flicker of something. Perhaps a dying white dwarf shedding its last warmth, or maybe the ghost of light stretched so thin it's barely visible. Photons that began their journey billions of years ago still travel, endless and untiring. They are the final storytellers, carrying with them the memory of everything that's ever shone. Every sunrise, every supernova, every quiet reflection in a pond. They all live on as travelling light. Even when the last observer is gone, those photons will continue through space, eternal messengers of a story that never stops being told. You can almost imagine one of those photons striking an alien world in another epoch, far beyond this one, sparking the curiosity of new minds. Maybe consciousness will rise again somewhere, fashioned from new matter under new laws. Maybe it will look up, as humans once did, and wonder who came before. The universe, it seems, has a fondness for repetition. Patterns repeat. Creation, curiosity, collapse, renewal. Like the verses of a song sung in a language older than time. Historians still argue whether the cosmos is conscious in any way, whether the order and symmetry found in its laws suggest awareness or simply coincidence. Most scientists, ever cautious, deny such notions. But drifting here, surrounded by this vast and harmonious machinery, it's hard not to feel a kind of intelligence in it. Not thought, perhaps, but intention, an artistry that expresses itself through balance and inevitability. Maybe consciousness isn't an accident at all. Maybe it's the universe looking in the mirror and recognizing itself just briefly before moving on. You move closer to the last stars still burning, faint red dwarfs that will shine for trillions of years longer than any others. Their glow is weak but steady, like the pulse of something refusing to quit. Around one of them, a small frozen planet completes its orbit. It's quiet there, no sound, no wind, no movement, but you can almost imagine a whisper lingering in the air. Remember, it's not a command, but a reassurance. The universe remembers everything. It carries every moment, every spark, in its expanding heart. There's a peace in that thought. The Big Bang may have been loud, violent and brief, but everything since has been an echo of that first note. Each atom, each photon, each thought of wonder is part of its reverberation. You realize that the story never really left that first instant. It only stretched, slowed, and changed shape. The way sound becomes music when given time. The Big Bang is still happening in a sense. You're just living in its quieter measures. You glance once more across the dark expanse where the faintest glimmers of ancient light fade into distance. The universe, for all its vastness, feels intimate now. You've traced its life from singularity to silence, from chaos to calm, and somehow the arc feels complete. The journey was never just about understanding how the universe began. It was about recognizing that you are part of it, inseparable and eternal, a small flicker in an infinite flame. You let yourself drift into that realization fully, your thoughts dissolving into the fabric of space, your awareness blending with the quiet hum of expansion. The galaxies fade, the light dims, and you find yourself floating not in emptiness but in fullness, a universe still singing softly, even in its long good night. You drift now into the deepest quiet of all, a silence that feels complete but not lonely, a silence that hums with the soft memory of everything that ever was. The light has stretched almost beyond reach, the stars have grown dim, and the galaxies, those grand islands of fire and dust, have drifted so far apart that even their faint gravity no longer binds them. The universe, vast and patient, has entered its final rhythm. It is no longer young or middle-aged, but timeless. What remains is not death exactly, but a long exhalation, a cosmic sigh after an eternity of motion. You look around and realize that everything is slower now. Space is still expanding, but the change is imperceptible, like the widening of a ripple across a frozen lake. There are no more brilliant blue stars, no more blazing quasars. What remains are the quiet red dwarfs and the faint embers of white dwarfs, cooling inch by inch into blackness. The last galaxies are pale ghosts, their light stretched into wavelengths too long for eyes to see. Even the background radiation, the oldest echo of the Big Bang, has cooled to near absolute zero. It's no longer a hiss, but a whisper below sound. You can feel it only as texture, a soft vibration that fills everything. This is the era cosmologists once called the degenerate age, when the grand processes of fusion have ended and all energy has settled into embers. Matter itself is sparse, thinly scattered across distances so enormous that each particle might as well be alone. The last black holes, those voracious anchors of galaxies, have begun to fade through Hawking radiation. Their decay is unimaginably slow, trillions upon trillions of years, but in time, even they will vanish, leaving behind nothing but warmth too faint to measure. The universe will have achieved perfect stillness, a balance so complete it erases the very notion of change. You might think of this as an ending, but it doesn't feel like one. It feels serene, like the quiet after the final note of a song, when the echo lingers in the air just long enough to remind you it happened. The Big Bang was not only an explosion outward, but a promise that energy would dance, transform, and eventually rest. What you're seeing now is that promise kept. There's a curious symmetry in it all. The universe began as a singularity, infinitely hot, dense, and small, and now it has stretched into near infinity, cold and diffuse. Beginning and end mirror each other, one filled with light too blinding to see, the other with darkness too gentle to fear. Historians still argue whether this symmetry suggests purpose, or whether it's just the way mathematics behaves when given enough time. Maybe it doesn't matter. Maybe the beauty lies precisely in the absence of meaning, the way a snowflake's pattern needs no reason to exist other than that it can. You drift past the remnants of what was once a galaxy, now a faint cloud of dark matter and cold stellar remnants. Each object moves with the inertia of a memory, slow, soft, inevitable. You can sense time stretching here, so long that even the word trillion has lost its usefulness. In this slow, diluted cosmos, the lifespan of a single atom could span epochs. Everything has loosened its grip on urgency. The cosmos has nowhere left to go, and that oddly feels peaceful. A few philosophers and physicists once speculated that this era might not be eternal after all, that somewhere, in the quantum fabric of the vacuum, fluctuations could still occur. Tiny sparks of energy might by sheer chance create new space, new universes. Perhaps one of them has already begun, an invisible ripple far beyond what you can perceive. If so, you're watching the grandest continuity imaginable, the universe dreaming itself anew. In that sense, the Big Bang never truly ended. It merely changed key, shifted tempo, and began again in another form. You think back to the earliest moments of your journey, to that trembling singularity, that first exhalation of heat and light, and realize that this final stillness feels like coming full circle. The beginning was filled with chaos, the end with calm, and between them lies everything: stars, planets, consciousness, love, loss, and all the endless asking that defined intelligent life. The Big Bang wasn't just the start of matter and energy, it was the start of questions. Every telescope, every whispered "why?", every spark of curiosity was part of that same expansion. The universe didn't just give rise to observers, it became one. Here's a gentle, almost mischievous thought to keep you company in this cosmic twilight. Maybe the universe never really cared whether it was understood. Maybe understanding was always a trick of perspective, a brief illusion granted to conscious matter before it dissolved back into the whole. And maybe that's okay. The stars never asked for witnesses, and yet they burned beautifully all the same. You let yourself float into the silence. The expansion continues, but you no longer measure it. Time continues, but you no longer count it. The boundary between you and it has blurred completely, as though consciousness itself has melted into the vast cooling sea of existence. The universe is no longer something you observe, it's something you are. And then, in that perfect quiet, you feel the smallest tremor. A quantum flicker, a ripple in the vacuum. It could be nothing, or it could be everything. Perhaps a new singularity, tiny and trembling, forming in the cold. Perhaps the next verse of the cosmic song tuning itself to the same eternal rhythm. You smile, if smiling was still a thing here, and realize that beginnings and endings are only ever words we invent to make peace with infinity. The silence deepens. The hum fades to a breath. The last photon slips away into the dark. But in that darkness, there's still presence, still balance, still the faint, unbroken thread of being. The Big Bang, the universe, all of it. It was never a story about explosions. It was always about expansion, of space, of time, of wonder. You close your eyes and rest in that expansion, feeling it stretch forever. The universe exhales one final time, not in loss but in completion. Everything is one, everything is still, everything is whole.